Ladies and gentlemen, welcome back to another live stream. So, we had like a series of Vulkan, raw Vulkan in Zig with SDL3 before, so we had made like I think 3 parts or 4 of them. We got like an OBJ mesh into the screen with a Skybox and so on, which was pretty fun. And in today's live stream we're gonna try to basically get to the same result but using SDL3 GPU. So we could only have one dependency, which is SDL3, at least in terms of like graphics. Although of course we're going to be using Z algebra for the math. We're going to be using, let me share the stream really quickly here. Alrighty, SDL. And we're good. Okay. Alrighty. So yeah, that's gonna be a lot of fun. I'm very excited. We're definitely gonna be assisting with AI, so if it's not your cup of tea, then probably this live stream is not for you. Yeah. Alright, let's just wait a few minutes while people can join in if they're interested. You can also join the Discord server in the description, I believe. Hopefully I've changed that. I just realized that maybe I haven't changed that, but anyways. Yeah, is the stream public? I wonder. Let me check if the stream is running. Okay, we're gonna be starting in a few minutes while people that are interested join in. Hello, Theo Paris, Radman. Welcome back. Okay, so we're gonna start at the 5-minute mark, pretty much. Let's start there. Okay, so I guess we're gonna get started already. Alright, fine. Let's go. Let's open up VS Code and let's start a new project. So let's go inside of dev, and we're gonna create a new directory called SDL3. I'm actually gonna make this into a library, so like it's gonna be a library and executable at the same time. So we're gonna be kind of like abstracting the boilerplate, and we're gonna be using or assisting with AI to really go through it very quickly, and also obviously the examples. So we're gonna be doing a lot of copy pasting and stuff. But yeah, now obviously if you do want to learn it, you're probably better off maybe look into my past live streams where I actually typed out everything, I believe. Yeah, and I was maybe going through it without like AI and stuff. But in this live stream, we're just like focusing mostly on getting stuff done and, you know, just chilling, chatting, and yeah, just to make it clear what's going on. Anyways, let's go into it. So let's go inside of SDL3, and let's say zig init. So we're gonna be trying a new, not a new, but like a binding, a zig binding, SDL3. I don't know, I have never tried it before, so I'm not sure if it's gonna work for our case or not, or if it have some weird bugs or whatever. But we're gonna try it. If it doesn't work, we're gonna just use the raw binding as we've done with the Vulkan series and stuff. So yeah. Hello Mucho, welcome back to the live stream. Okay, so yeah, let's try this and see for ourselves if it's gonna work. Great. If not, we can do something else. All right. Okay, let's actually launch VS Code here and let's go. We don't need this. And what we're gonna do here, oh yeah, let's actually add that zig SDL3, zig fetch. Perfect. Now let's just copy this thing and let's go to build.zig. Let's go down and let's paste it there. Let's remove all this stuff, we don't need it, and at least for now. And yeah, let's actually set up all the dependencies we're gonna need from now. So I'm gonna also be using Z-algebra as I've done with the Vulkan series. So Z-algebra zig. In fact, you know what? Let's go to my github.com, and I'm gonna go to my wiki kodotaku zig and gonna like just copy some of the dependencies there. Kodotaku zig vk. Want to join the stream yesterday also, but missed it because I zoned out. Yeah, it's fine, it's fine. All right, so build.zig.zone, and here we go. So we're only going to be needing Z-algebra and OBJ, so these libraries, zig libraries, right? So let's go to zig zone here and let's add them here after SDL3. And we're good to go. Now what we're gonna do also is copy the build.zig to this part right here, Z-algebra and OBJ. Perfection. Now since we're gonna be making this into a library, anybody who's gonna be using our library won't need to actually include this stuff, they would just have it. So yeah, that's gonna be a lot of fun. I'm not sure how it's gonna turn out, but we'll see. We'll see. So we're gonna put this into build.zig and we're gonna put it here. Perfect. And yeah, that's great. Now let's just make sure that we're building this. And SDL3 use local constant. Oh yeah, did I forgot something? Yep, I forgot this. Okay, let's add this here. And instead of lib, wait, use if in declare identifier lib. I mean, what is it called? I think it's called mod, not lib. I'm not sure why the readme is always wrong, but okay. And maybe just like mod add import. Yeah, I think so. So if like we go to this, there you go. So this is like the root kind of like library that people would basically like import. And for the executable, we're just gonna have this for testing, for our own testing of the library. But yeah. Now zig build, though honestly I had like some issues with like linking SDL3 to the library instead of the executable, so I'm not sure what's wrong with that, and is it like a binding problem or is it SDL3 problem? I'm not sure. So for now, we're just gonna keep it this way. And yeah, so let's just go with exe.root module, add import. All right, it's SDL now, new project. So what are you gonna do? SDL3 GPU, we're gonna be making a library for to basically abstract the boilerplate of SDL. And we're gonna try to get into like this live stream, we're gonna try to reach the level we reached in the Vulkan series. So yeah. So we're kind of like gonna be making like, let's say, some sort of game engine or just like a SDL3 GPU helper in Zig. With some added stuff like Z algebra and OBJ, etc. Anyways, let's see what we're gonna do. So the executable should have that. Where is the executable here? There we go. Use LVM true and use LD, because I'm on Arch Linux, which had like a regression GCC, so we need to use LVM compiler instead of Zig. So let's go. And boom. Sick. Now let's grab the example. There you go. Put it in src main.zig and zig build run. And there you go. So right now we're using the Zig binding. And this is what it looks like. So you just kind of like go SDL3 video subsystem.window.init. Hello SDL, so like give it the title, the width, the height, and the flags, and then you say defer window the init. So we don't have to create our own abstractions and stuff. Here, same thing with SDL3 init, SDL3 quit, and stuff like that. Pretty sick. Defer SDL3 shutdown. Clean up all initialized subsystems. Oh, I see. Any reason for SDL GPU over just Vulkan? I have a Vulkan series, and in fact, I may still continue that one. We're just trying the same thing with the SDL3 GPU because I was curious about it. But like if you want the Vulkan series, you can find it like live streams of it here too. Here is it, I think. Yeah, so in fact, let me show you what we got into the, where is it? I think I posted it in here, yeah. So here's what we got with the Vulkan live stream so far. We just got like a skybox and a mesh with a texture, and we're gonna try to do the exact same thing with SDL3 GPU in today's live stream. So obviously the Vulkan live stream took like around 3 streams, like 10 hours to get that result. So hopefully we could do all of that using SDL3 GPU today. I'm not sure if we're gonna be able to, but hopefully, especially since I already learned some lessons from the Kodotaku Zig VK stream and project, like which dependencies to use, like which math library to use, how to use, etc., and also the OBJ library and so on. So we're gonna basically applying that into SDL, and hopefully we're gonna also make a library which gonna take care of the boilerplate code for people who include our library. So like you just link in SDL Kodotaku and you get all of this dependencies and you get some abstractions to get off the boilerplate code, because even SDL3 GPU have a lot of boilerplate code. And I don't like this FPS capper, it's just like an extra. Let me see what extras they include here. So they included like an FPS thing. Yeah, nothing fancy. All right. So let's just remove this FPS capper. I don't like it. That's nice. Are you using Gota's bind? Yeah, exactly. I'm going to be trying that. I've never tried that before, so I'm going to be trying it in this stream. If it works, great. We're going to go with it. If it doesn't, then we're just going to go back to the C binding. Hopefully that wouldn't happen. Or maybe even we try to like contribute, like 4 can contribute to the binding. I don't know. We'll see. We'll see how that even goes. So this is just a chill live stream pretty much. We're going to be trying this together. So all right, so what we got? Great. Great. Okay, so what we're gonna do now? All right, so we're gonna be following with the Zig examples of GPU, like Zig. Wait, SDL3 GPU. My bad. Examples. So there's this guy right here, this repo, and they have a lot of examples. All right, I mean, in fact, let's try to do stuff on our own first, so at least we have something to work with. So we're gonna be creating an app.zig, I think, or let's call it maybe core.zig, just like we've done with Vulkan, I think. So it would basically include all the boilerplate code for us. Take care of that, and it just gives you a window where you can render to and stuff. All right, so core.zig, cool. And what we're gonna need here is SDL3 and std, that's for sure. And we're gonna have const self is equal to this. They're quite good. I went to see bindings, but only to learn more. Yeah, we'll see today. That's great to hear. I'll see how it goes. All right, so window SDL3.video.window, right? Cool. And we're also gonna have an SDL3 GPU device, so SDL. Now later on we're gonna be helping with the AI to generate stuff, but right now, since we still doesn't have any code for the AI to kind of like base from, like the context essentially, so we don't really have much to work with right now, especially since we're using like custom like zig binding instead of like the raw SDL binding. But yeah, anyways, so we're gonna go with GPU device, I guess. Well, it's probably in GPU subsystem. There we go. Sick. Cool. And what we're gonna need next, so if we go to common.c here, okay, common.h, so we got the window and we got the device. I think that's all for now. Yeah, I think that's all for now. Cool. So we're gonna say pubfn init, and we're gonna go with error or self, and we're gonna create a window. Well, actually, so we're just gonna copy this part, really. Let's just copy this part, and here we're just initializing the video subsystem. Cool. But here, instead of defer, we're gonna say error defer, and here again error defer. Now screen width and screen height, we're just gonna say width and height, but we're also gonna need the title though, so you know, let's just come here and grab all of this. Well, only up to here, I think. And let's just grab this here, and now we're just gonna pass in the title. So we're just gonna assume that we're only gonna have one window to keep things very simple. In fact, I have actually tried to make SDL3 work with multiple windows before in C, and while it worked out just fine, but it was kind of clunky. There was a lot of questions like about synchronization and so on, so I'm not sure if they even have like battle test that yet, like multiple windows, because most people don't use multiple windows anyways. But yeah, all right, let's go with width, let's go with height. Dodge, what we're gonna go with here, we're gonna keep it hidden at first and then show it once we're ready to render stuff. And what else do I want? I also want it to be resizable, that's for sure. Anything else? I don't think. That's all. Sick. What's next? What's next? Yeah, let's create the device right now. So const device is equal to try SDL3.video, well actually .gpu.device .init, and here the shader format, we're just going to include all the formats. So .spurv for Vulkan, .dxil for what is it called, DirectX, and MSL for Metal API. There we go. And for the debug mode, I mean, I don't know, we could get it as a variable. Fine. Debug mode, and the name of the driver, we could also get that as a variable too. In fact, you know what I'm gonna do? I'm gonna create a little info struct so we could have defaults and stuff, because this gets really clunky to have all the arguments in the function call. So we're gonna have a struct info, and we're just gonna have the title, that's required, and the width and the height also required, obviously. And other than that, we're gonna have the debug mode. So the debug mode is a boolean, and by default, I guess let's set it to true, I think, or let's just keep it fine without defaults. Why not? And for the name, well, we're gonna say now info.debug mode. I installed CacheOS on my ThinkPad. Are you proud? Yeah, CacheOS is pretty good. Though for your ThinkPad, like anything would work, any distro would work. But like, especially if you're like me, have an NVIDIA GPU, oh my god. All right, or a desktop in general. Cool. Let's go info.debug mode and info.driver name. I think that's the driver name, right? So we're just gonna grab this part right here. So driver name. And by default, it's null. And yeah. And here we're just gonna say info.driver name. Cool. And now here info.channel, info.width, and info.height, and we're good. Is there anything else? No. So now that we create the device, we're gonna own the window. So how we're gonna do that? SDL3.gpu. Actually, no. I think maybe it's inside of device, possibly. Is that the case? Yeah, claim window. There you go. Claim window, and then you give it the window that you want to claim, and you're good to go. Now, obviously, this could fail, right? Yep. So we're gonna say try. Oh my god, I love this code. It's pretty. Look at that. Like Zig is so elegant, you know. Anyways, so what we're gonna do now? We're gonna just return the window and the device stuff. All right. So return.device, device, and window is equal to window. And there we go. Is there anything else? Let's see. Common.c. So just creating GPU device, we're creating the window and claiming the window, and that's all. So right now we're just gonna make sure that you have like the dinit function too. And honestly, we could make the device first. Why not? And yeah, so the device first. Not important, but makes sense. Pubfn dinit. Now for the dinit here, we're gonna say void, and it's gonna take in self, right? And you're gonna say self dot. Well, first of all, device, yeah, self.device, the release window, I think, window, self.window, and we're gonna say self.device, well, .window.destroy, right? dinit, okay, and self. What is it called? Device, window, and device itself, right? So dinit, and there we go. So that's the dinit function. Now let's see what's next. So let's go to the triangle example. Triangle. Where's the triangle? Oh, well, let's go to clear screen. Right, fine. Alright, so here we initialize. Great. Next step, we actually acquire the GPU command buffer. Alright, and we wait and acquire the GPU swap chain texture, and we create a render pass, and we submit the GPU command buffer. Sick. So what we're gonna do here is we're gonna have like a pubfn begin frame, or should we just call it begin? Yeah, fine, whatever. Self, and let's say void, or man, my OCD brain is going insane. Anyways, begin frame, and we're gonna go with an error here, and let's see. So const command buffer, or yeah, command buffer, is equal to self.device.acquire command buffer, and we're gonna try this. Next up, what we're gonna do is we're gonna acquire the swap chain texture. So const swap chain texture, I guess, is equal to try self.device dot well, wait for swap chain, I guess. Block the thread until it's available to be acquired, and it gives me back what? Nothing. What? So how does it work then? Wait and acquire GPU swap chain texture. You know what? We could search or see what's happening here. No, this is just waiting for a swap chain texture. What? Can we find some? Let's search in the repo where they're calling that. Fine. Where's the search here? I hate this interface. Oh my god, I'm used to GitHub. Where's this research thing? Doesn't seem like here. Well, I guess maybe we could search in Zcash or something. Or actually we could search in here. My bad. let's search in here. There we go. Wait and acquire GPU swap chain texture. But where is this? Oh, is it in the command buffer? Okay. There we go. Acquire swap chain texture. Wait and acquire. If you use this acquire, you're gonna get a memory leak. You know, so please make sure to use this. And there we go. So, because like a lot of time that bited me before. And here we're gonna go with self.window. I mean, it would work out just fine, but it's gonna be memory leaking stuff. But yeah. So this actually gives us a struct. Is there like destructure in Zig by any chance? Yeah, it's just an anonymous struct. That's interesting. Well, let's see. Does Zig have struct destructuring? Structuring. Oh, so you do this, huh? Okay, let's try it. So I guess you say texture and the width and the height. Is that it? Huh. Did it just like... It probably just... What? Nah, I don't think that works. Well, you know what? Let's call this swap chain texture. Or swap chain. Swap chain texture, fine, whichever, who cares. And then what we're gonna do next. I hate how I like get rage baited by such simple things. Anyways, if swap chain texture not equal to null, and okay, so basically if swap chain texture dot dot 0 and texture. And so if we got a texture, what we're gonna do is we're gonna do this stuff. We're gonna begin a GPU render pass. So we're gonna say self dot, let me zoom in a bit, self dot device or window begin, no, I think command buffer, yeah, probably command buffer, yeah. Begin GPU render pass. There you go, begin render pass, and here you give it the color target info. Color target info. So I guess you do it like this, right? And then you say, how do you say color target info? SDL3.color, no, GPU.color target info. There you go. And then you could fill this up. And here the depth stencil target info. For now it's gonna be null. Alrighty, and this would give us back a render pass. So const render pass is equal to that, and then we're gonna defer render pass dot. Oh, sick! So the render pass have all these functions. Nice, love that. Defer render pass dot end, and what we're gonna do next is submit the GPU command buffer here. You're gonna set the texture, the clear color. Okay. So let's go ahead and do this. Dot texture is equal to texture. Dot clear color is equal to R is dash. Let's say this, and dot B is equal to this, and dot A is equal to this. And what else? Or is there like a helper function to create like a color in SDL? No, doesn't seem like it. Next up, we got the Lloyd OP and the store OP. So for the Lloyd, clear, and for the store, I guess store. There we go. That's so freaking sick. Okay, another thing we're gonna here do is defer command buffer dot submit, I guess, maybe? Or should we do that? Yeah, I mean, for now I guess it's fine. And we're good. Well, this is not just begin frame. This is more than that. For now, let's just call this frame, and we'll see about that later on. And we're good. So now let's actually try this code. Let's try this. So what we're gonna do, let's go to main.zig and let's remove this stuff, I guess. So git surface fill rect update. Yeah, let's just, I don't know, let's say const core is equal to import core.zig. And there we go. Now we're just gonna say we still need the pull event stuff too, but we'll see. Anyways, so let's just say core here. So const core, or var probably. Let's go with const. Core is equal to core, well, dot core. So dot, oh yeah, actually it's already core, right? So let's just say this, and let's say core dot init. And here you give it the info, which is basically in our case debug mode true, and the title, the width, and the height. So the title is equal to code.chaco, or SDL code.chaco. And what else? The width is equal to 800. The height is equal to 600. And we're good. Okay, sick. So now what we're gonna do here is remove this part and say core dot try core dot frame, and here we need SDL3. The stream is lagging. Doesn't seem like there's any dropped frames, so yeah, there doesn't seem to be any dropped frames. Alright, so here we got while SDL3 events.pull. We could just make this into a function in core. Pubfn init, and here let's say pubfn pull. Pull, and we're gonna say self void. I don't think we even need self in this case. Yeah, we don't. but let's just do this anyways. Let's return whichever this is, and pull is gonna give us like an optional event here, and we're good to go. Now what's up? SDL3.event, and we're good. So now we could say core.pull, and great. So does this works? Let's see. Okay, so we have a few errors here. Why? Expected type found const. Yep, let's make this var. And by the way, defer core.dinit. And consider using try. Yep, try core frame. And let's go. Error union is ignored. Command buffer.submit. There we go. Defer try command buffer. Oh, try not allowed inside defer expression. That's interesting. I'm not sure what's up with that, but let's just put it here then. Why not? And next, root source file has no member named event. What's up with that? SDL3.events.event. Yep. And boom. Okay. And we're not getting anything into this. Oh yeah, I didn't show the window. I always forget about this part. And hello data043, welcome to livestream. Well, window.show, there we go. And does this fail by any chance? It does. So let's say try. And boom. All right, so we got our clear window. Perfect. And in our application code, we only have this stuff right here. So, but let's actually destructure this frame here right now. So what we basically want to happen here is we're going to have like an begin frame. Because we don't want our core to actually like render. We want our application to render, or whichever other abstraction. Our core is only supposed to handle the, you know, all the boilerplate code out of our face, pretty much. So what we're gonna say, we're gonna grab a command buffer and a swap chain texture. And what's up? What's going on here? Why? Oh yeah. So it should be, so what this would give. So we got like a command buffer and a swap chain texture. We could use that struct, or we could have like a frame struct. That also would work. Actually, that's genius. You know why? So we could have like a pubfn end frame, and you can't call that end frame without having a frame struct first from begin frame. So that's kind of like the API design there. Yeah. So let's say const frame is equal to a struct, and you're gonna have a command buffer. Well, SDL3.gpu, I guess, .command buffer. There we go. And we're gonna have a swap chain texture. So texture essentially. And it's gonna be SDL3.gpu.texture. And we're also gonna have what else? A width and a height. Yep. But can't you actually get it? No, we can't. Alright. Whichever. So we're gonna say U32 and the height is U32. And there you go. That's sick. So now what we're gonna do is we're gonna bring this here. And in fact, you either gonna get a frame or you wouldn't. So we're gonna do this. And we're gonna say if we actually wait, should we begin? No. Because we could want to do some other stuff other than the render path, so we're not gonna hard code that part. So let's just only do this part right here. So if we got a swap chain texture, then great. We're gonna return a frame. So return a frame. And why it's not I'm not sure why it doesn't do that. That's weird, but fine. Let's just say return frame dot command buffer is equal to command buffer, and dot texture is equal to swap chain dot 0, and the what else? Texture. The width is equal to swap chain texture dot 1, and dot height is equal to swap chain texture dot 2. And I'll say let's just call this swap chain instead of, yeah, let's call it swap chain. Fine, whatever. And we're good. Okay. Does that seem great? Actually make this texture here, and yeah, perfect. Otherwise we're just gonna return I guess null, right? And that's begin frame, and finally end frame. Now end frame, it's gonna take self, and return. Well, it's actually also gonna take frame, and it's gonna return what? Just error or void, I think. And we're good. Now we're gonna do this command buffer submit, and honestly that's pretty much it, I believe. Yep. And there we go. So try command buffer submit. So frame dot command buffer dot submit, and function shadow declarations of frame. What does that mean? What frame it's talking about, bruh? Declared here. Oh, I see. So actually just remove this part, though we're gonna copy only the render pass here from here. And let's do this, and we're good. So now in our main.zig, instead of this, we're gonna say try core.begin frame. And this would return for us a frame. Well, it could be. It could give us a frame. So if begin frame, then we actually did get a frame. And we're gonna basically say frame dot. Actually, should we put the frame end in? Yeah, maybe. I mean, we could do that too. Should we do that? Or no, let's keep it raw. Fine. Let's say core.inFrame, and we're gonna give it the frame here, and here we're gonna do our render pass stuff, and we're gonna grab our command buffer from the frame. So const command buffer is equal to frame.command buffer, and here what we're gonna do, we're gonna need SDL3 here. Now what I'm gonna do for that, I'm just gonna say pub const out of here, and then we could just say const SDL3 is equal to core.sdl3. Great. What's next? Here we also gonna need the texture. So const texture is equal to frame.texture, and we're good. Now what's up? In used function parameter, an error union is ignored. Yeah, I see. So self is not being used in fact here. Well, fine. I guess let's just go with that design. Let's put a end here. Let's do this. And here we're actually gonna have self, which is gonna be a frame, and we're gonna say self.commandBuffer.submit. Oh, actually we could add some helper functions inside of the frame. Yeah, for the render pass stuff and so on, instead of having to do this. Yep. I'm not sure why I didn't think about that just until now. So we're gonna say frame.end here. Isn't that the case? Why can't? No, that's fine. Okay. And what now? End is not marked pub. Okay, so that's why. End is not marked public. So pub. And what's up now? Expected type found const. Yes. Where's the frame again? Yeah, I see. So, well, we could just grab it by value, right? Consider using try, sure. And boom. Oh, we got an insertion fail. wait, I think I know what's the problem here. So we got a begin render pass, and then we defer the render pass dot end. Well, not, so let's actually put this render pass in its own kind of block here. Because we're supposed to end the frame first, right? So before, sorry, I mean end the render pass first, then end the frame. Okay, next up we could actually add helper functions for begin render pass, for example. So let's grab this code and let's come here to core.zig. Let's add pubfn begin render pass. Or just render pass, really. Why bother? Self frame. And here you're gonna give you back, I think, a render pass, right? So SDL3.GPU.render pass. And let's go. Now self.command buffer, and we're gonna return the render pass. Whoops. Render pass. And here the texture. So we're gonna grab it from the, obviously from the frame, right? Well, obviously from self. And here the clear color, we're gonna get it here. So clear color is SDL3.GPU.clear. Oh, what? Where's the clear color? Oh, I think it's just in SDL. No? Bro, what? Pixels. Okay, so it's in the pixel subsystem. Pixels and F color. Let's go. And we're gonna give it here. And we're good to go. Now the other stuff, we may need resolve and MIP. Resolve, we may need it for MSAA later on, but at the point where we're gonna need it, we're just gonna refactor this little abstraction. But yeah, but for now we only need the clear color, and yeah, that's great. Great. Next up, instead of this business, we're just gonna say render pass. Well, frame, yeah, frame.render pass, and here we could set the red. And let's change up a bit. Let's do yellow color. Dot A is equal to 255. And this is gonna give you back a render pass. And you're gonna try that, and we're good. And we don't need this anymore, in fact. Great. And boom. Alright, now let's go to the next thing, which is a triangle. Right? I don't think there is anything else I want to abstract there. Yeah, not for now. Cool. Let's go to the triangle now. Triangle. Triangle, where is it? Now for the triangle, we're gonna need the compilation of SDL, and to be honest with you, I think I'm gonna start to use AI right now to, you know, go through that stuff really quickly, because it's just, again, boilerplate code. Well, where is that? Yeah, common.h, I believe, or common.c. Yeah, common.c, there we go. And we're just gonna copy this Lloyd shader, and let's see if the AI could help us cut down on time right here. Yeah, and let's try Claude. I haven't tried Claude a lot, so we're gonna try that. And let's give it this code. And let's give it our own code so we have some context of how the binding looks and so on. And in fact, since it's going to be dealing with the GPU, I don't know, let's just give it this, fine, core.zig. So translate this function to zig SDL3 binding. Here's some context. And we're good. Yeah, let's see what it's gonna do. It probably wouldn't be like perfect, but we could, you know, iterate on it and fix it. But you know, just getting something started. I mean, I could probably give you the binding. Hold on. What it needs again? It needs the GPU, SDL3 GPU. So where's SDL3 GPU here? Come on. There we go. And maybe I could copy this whole... No, it's too big. It's too huge. Huge. You know, let's just do it ourselves. Let's just copy this and see for ourselves what's gonna happen. Now, where are we gonna put that shader stuff though? I think just in the core. In fact, the shader backend formats and stuff, we're gonna fetch them at the init function, right? And we're just gonna reuse them every single time. All right, whichever. Let's just see what we could do here. Pubfn init dinit pull blah blah blah. Let's put it here. Why not? And let's see what we got. So first of all, this let's see, index of. So here it's auto detecting the shader stage from the extension of the file name. Sick, everything looking good though. Okay, cool. And here the backend formats. Let's get in the shader formats here. Sick. Now the shader backend. Now this stuff right here would be like the same thing for the whole backend, you know, so we're gonna cache this stuff. Really, we're gonna cache this stuff. So I'm gonna content shaders compiled backends up there. Yeah, stuff up until here, there is a lot of stuff that could be just cached. The stage that's needed, so we could just grab all this stuff, and here we're gonna have, instead of device, we're gonna have self. And let's go to the init function and let's put that stuff there. Now before the window show, in fact, you know what, we could say defer window.show, but no, it does have that try. Fine, whichever. So here we're also gonna need an allocator apparently for this, but we'll see about that. All right, so here we're getting the backend formats, perfect, and we got this shader backend struct. Why? Format, sub there, extent, and enter. Okay, so that's 6. So that's exactly what we need to like store, really. So that's lovely. So let's just grab this and put it into a struct here. So const shader backend, yeah, and let's just store this shader backend. So it contains the shader format. Wait, that's not format flags, I think. And the sub there const u8 extension entry points, perfect. All right, let's go. What's next? Get shader formats, shader backend. So spur v. Does this work? No. Wait, what? I don't. Is it? Wait, hold on. So SDL3.gpu. Whoops. Shader format flags dot. What? So there is like from SDL supported into SDL. Alright, we gotta figure out how this works. Well, it does actually have SPR-V and stuff, but it's not an enum, it's a struct, right? So for that, we should probably say this. .SPR-V is equal to true. I think that's kind of like what we need here, right? Wait. Why this is not working? Oh yeah, this. And there you go. Cool. Love that. And so we're just gonna like copy this part here, here, and here. And we're just gonna grab this here and here, and there we go. But no, wait, no, it doesn't work that way. It's that wouldn't work, I guess. Hold on. How we're using it here? I mean, what we're using it for? In fact, we don't even need this stuff, really. Yeah, I think we don't need. Yeah, we just need like the subdirectory, the extension, the entry point. So I think let's remove that, right? Why it's need that here? I'm confused. Let's look at the C code really quickly. And let's see where it's using that stuff. Okay, so it's just using it here to like actually figure out what's the back end. Yeah, I see. Yeah, so we don't need this stuff, right? We don't need. So we could remove it. Remove this part, I guess. Wait, format. Yeah, this whole part right here. Cool. Yeah, let's remove that. And let's remove it from here. And so we only need this stuff. And finally, we're gonna make a path. Now for the path, we gotta have a base path. Where's the base path? Bro, what? Where's the base path? Oh, we don't have a base path. So we're gonna grab that too. And the base path is basically SDL get base path. And we only do it once. So in fact, we're doing it here, so that's great. So const base path is equal to C, well, not C, SDL3 get base path. Well, no, GPU get base path. What? No. Where is it? I wonder. Maybe file stuff. Get base path. There we go. Perfect. Okay, and let's say try here. And so far the binding seems fine. And in the info right now, we're gonna add another thing, which is like the allocator. So std.mem.allocator, and we're gonna say info.allocator. And you're gonna say content shaders compiled. So here we don't have the shader file name, obviously, and the backend extension. Oh, in fact, we don't even like need to store the sub there in the path. Yeah, actually that's true. We only need to store this path and the extension. Yep. So like we could say instead shader ext here and call it a day, I think. Right or no? Yeah. So shader extension, we're gonna say, what's the, it's just a string, okay. So const UH, cool. And we're gonna grab a shader ext, okay. Now we're gonna remove this stuff. Great, and instead of that, we're gonna remove this, I think this part right here. Yeah, up to here. And we're good. And we're gonna defer allocator.free. No. So only error defer actually. And here we're gonna say info.allocator. And we're good. So we're gonna add right now the path to the shader. So shader path, or shader's path, or shader's base. Nah. Anyways, const UH. Or fine. Let's say shader's base path. Okay, and let's say dot shader's base path is equal to whichever that is, full path. Shader's base path. Cool, and we're good to go. And we're good. Though, yeah, that seems great. So now we could actually use it. So let's go back to the Lloyd shader here. So we got the shader file name. Yeah, we need all of that. We don't need the allocator since we're gonna probably store it. Let's actually store the allocator. And is equal to info.allocator. There we go. Is the stream still fine, by the way? Let me know. Auto detect the shader stage from the file name and std.mem index of shader file name .verge, then vertex fragment, and here Lloyd file full path. So here we're gonna create a path, and we're gonna have something similar to this basically. We're gonna do it here, and we're gonna have just this and this pretty much. And is the stream fine? Yeah, seems fine. All right, cool. And here what we're gonna do is self.allocator, and here shader self.shader's base path. What? Where's the shader's base? Oh, I haven't stored it. Where did I store that? I'm pretty sure I did put it somewhere. Oh yeah. No, I actually put it here now. That's not what I meant. Let's put it here instead. And we're good. So let's go back here. And you're gonna say shader's base path. And here, instead of backend the sub there, we're gonna say, what they did actually in the C code, I forgot already. Or just like the here, okay. So what they did, the shader file name, where they grabbed the shader file name? Yeah, the whole thing, okay. And the back, okay, fine. So let's just give it the file name, shader file name, and yeah, that's basically it. Now I'm just gonna call this file name actually. And sampler count, okay, that's sick. And here, instead of info, we're gonna say self. Though after we're done creating the shader, we probably don't need that path anymore, so we're just gonna defer and free that path. And this is the actual path, output path, or like just path, yeah. Shader path, and there we go. And we load that shader path, and we're good, pretty much. So self.device.create shader, and here the code and the entry point. Oh, we actually also need the entry point. Yep. So okay, shader entry point, or to simply just steal this one, I guess. And there we go. Yeah, in fact it was the exact kind of same thing here, but whichever. Anyways, so what we're gonna do now, we're gonna set it here. Well, no, not here. Here. So shader ext is equal to shader ext. Where's the shader? Oh yeah, it's in the backend .ext, and the shader entry point is in the backend entry point. Though yeah, to be honest with you, let's just store the backend instead, and just instead of having sub layer here, we're gonna have the base path. It's gonna be called the base path, and this is gonna be called the extension, and this is the entry point, and call it a day. But no, that's because we're still using that thing here. Never mind. Yeah, never mind. So let's just grab this struct and put it here then, why not? And we're good. Okay, fine. Let's just use this, please. So instead of backend entry point, we're gonna say self.shader entry point, and here, oh crap, we do need the shader format flags, huh? Well, fine, we could just add that too. You know what? You know what? Let's go here. Let's do this. And we're good. Now instead of having this, it's gonna say shader backend is equal to shader backend and call it a day. Where's the shader backend here? The backend, yeah, it's called backend. We should definitely like rename it. And we're good. Now we're gonna say self.shader_backend.entry point and self.shader_backend.format. Oh, I actually did remove the what the bruh. Okay, let's add it back. My god. Yeah, it's so confusing. Let's see, backend formats. Yeah, fine, let's add the format here, bruh. And let's add it. We added it into the right place, right? Yes, we did. So this one is, well, there we go. I'm just gonna copy this part, put it here, and instead of spurv here we're gonna say msl, and here we're gonna say dxil, and we're good to go. Lovely. Alright, now let's go back here. We don't need the base path anymore because we already got it stored, and we're good. Okay, so I think we're good now. Now dot format, and boom. Oh, that took too long. Okay. So what I'm doing here, just to recap, is that I'm kind of like pre-calculating and caching the base path of the shaders depending on the backend, right? And then later on in Lloyd shader, I don't do that calculations anymore. I just shader base path file name, boom. But yeah. All right, so let's actually try to load some shader now, and let's steal some shaders from here. So I'm just gonna grab this whole content thing. Yep, let's do that. So we don't waste time. Let's load the zip. Don't load the zip. Save. And oh well, extract here. And where is it? There we go. And let's just grab this content folder and let's put it here. and boom. Alright, now let's actually try to load something like the triangle shaders. So let's go to triangle, basic triangle.c, and what we're gonna do here. Yeah, we're gonna load the raw triangle.verge. We're also gonna need some pipeline code. But let's start by this, fine. Load shader. So let's go. So we're gonna say const shader is equal to core.load shader, and here the file name is raw triangle.verge, and the sampler count 0000. Now honestly, for that one, you know what I'm gonna do? I'm gonna put this into its own struct. So like struct shader. What this is called? I forgot what these things are called. They have a name. I don't know. Shader F. And let's just say const shader options. Or actually, you know, let's just make a shader info struct, and let's have this in here. And actually put the file name here too, why not? And let's just have the info here. So shader info, boom, and we're good. Now what we could do is that we could give this defaults like 0, 0, 0, 0, and we're good to go. And now here what we're gonna do is we're gonna grab this parch. I'm gonna say dot file name is equal to this, and we're good. That's sick. So we're gonna try to load that. So this is our vertex shader, and finally this is our fragment shader. Now obviously we're gonna make sure to defer vertex shader.dnh, I believe. Oh, what? Wait, what this returns? It returns this. Doesn't it have like a DNH function, or? I mean, yeah, it doesn't seem like it. Maybe we don't DNH. Yeah, we don't. It's not like Vulkan, I guess. Fine. Okay, so we're good now. So we're just gonna say this vertex shader and fragment shader. Now let's see the actual errors. And use of undeclared identifier file name. Yep, info dot file name. And here too, info dot file name. Oh boy, so let's just say info dot and I guess we're good. Next, allocator core.init. Yep. Oh, the allocator. Okay, so let's make a GPA here. So var GPA is equal to std. Do we have std here? We don't. So let's say const std is equal to import std and std.heap dot general purpose allocator dot init, and actually let's call this GPA allocator, and then defer std.debug.search that GPA allocator is equal to OK, I guess. Well, .dinit is equal to .ok instead of leaking. And we're gonna have finally constant GPA is equal to GPA allocator.allocator, boom, and great. Now we can add this allocator here, so GPA dot, well, just GPA, yeah, right. And boom, good. Next. So there is no alloc print z. Perfect. Let's find out what it is really. So there's only like alloc print sentinel. And there's even comp time print. Huh. That's interesting. Let's feed it into the AI really quick. Yeah, it should be like null terminated, so we're gonna do this kinda. Alloc print sentinel. Yes. Okay, fine, let's do that. So here I'm gonna say sentinel. Well, let's remove this and let's just say alloc print sentinel. And we're gonna do the exact same thing maybe for the other one, isn't it? Or do we actually need the sentinel here? I don't think so. But let's just see what's gonna happen here. So shaders path. Oh, we're gonna definitely need it for this Lloyd file thing, but I don't think we need the sentinel there. Yeah, we definitely don't. But you know, fine, whichever. Expected for arguments found 3. What are the... oh, a sentinel. So I guess 0. Yep. So let's add the sentinel in the other place too. 0, and we're good. And oh man, root struct has no member Lloyd file. Yep. So we're gonna say try SDL3 dot file system dot Lloyd. Oh, what? Where is Lloyd file? Huh. I'm kind of confused. Let's see where they're calling Lloyd file. What? There's no Lloyd file here? That's weird. Yep, there's none there. That's strange. I'm gonna come back in a second. Okay, back. Stream still fine. Yeah, seems so. Alright. So apparently we have a problem. We don't have Lloyd file in the... So you know what we could do? There's two ways we could do this now. We could either... did I unmute my mic? Yes, I did. We could either use the C function directly. I think .c, yep. Oops. I believe maybe an IOStream instead of file system. Oh, really? Oh yeah, cool. Thank you, Entry and welcome to livestream. There we go. That's sick. So Lloyd file, or we could use like Zig file system stuff, but man, let's just go with SDL for now. So Lloyd file, and what we had here, I already forgot, bruh. Let's go look into the code that we had. Path. Yeah, path, my bad. So where's the path? There we go, shader path. So shader path, and we're good. Okay, so that's the code. And free SDL3.free. Okay, that's cool. And yeah, we should be good to go now, maybe. Let's see. So no field named entry point instruct GPU shader info. Oh yeah. Wait, what? It's called entry point like this. There we go. Okay, so... But there is a little problem here for whichever reason. Memory address leaked in array list. Where exactly? Oh yeah. So the init, we're gonna say self.shader space path. Well, self.allocator.free. Or no, yeah, actually that's good. That's good, my bad. So we're good. Let's go. What else? I don't think that was the only problem here, isn't it? That's weird. Clear and try again. And let's see what we got. So allocation size does not match free size. Bro. Is there some weird thing with the alloc print sentinel thing? You know, let's not waste time on this. Let's just ask the AI really quickly. Let's go. Oh, what? Oh man. I'm like, what? Can you just remove this thing that I pasted here? Size mismatch on free. However, relying on a null. I'm confused where the problem is. But the field shader has length, not so free, freeze GPU cast mismatch. Okay, but how I'm supposed... I mean, I kind of understand is that like alloc print sentinel. Oh, do you need to maybe say free sentinel or something like that? No. What? Do I have to like construct the thing myself? Shader base path. You know, let's actually use alloc print please here. Because what the heck was that? And expected 3 arguments found. Let's remove this. Whoops. Now we have some SDL error, but what is exactly that SDL error? It doesn't actually tell us. Copy. Sure, let's try that. I guess here. Well, 5-minute break. Zig build run, and let's see. So loading shader from... Oh, it's trying to load it from zig out bin. That's interesting. So I guess maybe we could... Nah, I think SDL itself just does that. So, alright, let's just, for now, let's just copy this manually into zig-out. Not the best solution for now, but it should work. And let's see. So, loading shader from zig out slash... Oh, actually in bin. So it's still having a problem, but it's not telling us the SDL error. That's very strange. Well, loading shader from... Can you cat this path really quickly, just to make sure? Well, obviously the SPV. Yeah, the path is correct. The problem that I have here is why it's not printing the SDL error. Whoops. We're checking. There we go. Error callback. What error callback you have by default? Oh, here it's a thread local error. Who's using this error? Like, who's actually setting this stuff? That's weird. Oh boy. Signal out of memory. Yeah, I'm not sure where the problem is. So, for whichever reason, it's erroring on SDL3 Lloyd file on shader path. Now the shader path seems correct here. Yeah. And it's not giving me the error exactly. I guess let's try to debug this maybe. I mean, I'm using SDL base path, so it should work, and it's actually an absolute path here. And it is supposed to give me the exact error message if there was really some error. But it's not. So you know what? Let's go to my project. Let me steal this ledge.json. Actually, let's just only need the LDB pretty printers first. So let's copy that, and or let's just doloid that really quickly, and let's put it here, and let's grab that VS Code ledge.json. Okay, VS Code. launch.json, and instead of kodochaku zigvk, you're gonna say SDL kodochaku, and let's come here and let's put some, yeah, let's go to core.zig and let's go here. Now let's run this and debug. So hopefully we have at least a better idea of what the heck is going on here. Okay, so you got like the shader path. So that looks good. Alright, and then what's happening? So if we go inside of it, wait, why the length is whatever this is? PTR cast, align cast. Does the path have a raw sentinel? I mean, I guess should be. Log print sentinel 0. So it should have okay, whichever. Let's go inside, I guess. Oh, what? Oh, wait. Why? Oh, yeah, because it failed, right? Yeah, but like, where's the error? Yeah, that's really not helpful at all, my god. Okay, let's do this here, okay? Let's try. Okay, and continue. Let's go. And the error callback is... Bruh. No way. Super confused. Let's try some other LLM, because what the heck is this, bro? Let's try ChatGPT. And let's just zig build run. I can't believe I spent all this time on such a little thing. Could it be like why it's not giving me the problem? That's what I have a problem with here. You know what I'm gonna do? I'm just gonna do something here, okay? I'm gonna try to do, I think Goddess Binding has a way to get the error with SDL.errors.get. Not sure if it'll be more specific. Yeah, I mean, like by default it should just freaking like print the error, so. But let's try that. Let's see if that even exists. So well, let's do it. Error defer this. There we go. This is the error. No such file or directory. Why Goddess Binding doesn't like print the errors by default? Like, bro. Oh, it's actually trying to... Bro, come on. What happened with the SPV? Bugs, my god. Well, where's that? Shader's path. Oh my god, bro. Ah, oh, come on. Oh boy. Oh boy, oh boy. Whichever. Let's continue. So what we're gonna do here, self.shader.ext. Yeah, where's the shader backend.ext? My god. What really sucked is that the Gota binding doesn't like print the error by default, so I was like in the dark this whole time. I didn't even know what was wrong, first of all. Oh my. Okay. Alright, we at least loaded the shader. I don't know how much time I spent on this bug. I just like forgot the extension. Oh boy. Anyways, whichever. But really, I really need to find out a way to change the callback so it prints the error next time, at the very least. Because that's such a bad default error callback. Or maybe I just missed something that, but meh, I don't know. Anyways, let's go to main.zig, I guess, or let's go to core.zig where we initialize that stuff, and let's see if there was like a way to, like, does the binary actually even have examples by any chance? Let me see. Oh boy. Okay, so there's quite a lot of examples here. One of them that is very interesting is the SDL callbacks, which is cool. Yeah, I would definitely use that. Maybe. Yep. Yeah, I would try that. But other than that, what else? So, do they set like some sort of wait, set memory functions by... Oh boy. You know what? We could actually set the SDL3 memory functions like alloc and free to the actual debug allocator. So right now we would catch even like the SDL leaks. That's insane, bruh. That's insane. So what we're gonna do, also defer SDL3 shutdown. Did I actually handle that properly? Let's see. So try SDL, error defer, quit. Where is error defer? Shut down SDL. But like, isn't quit enough? I don't understand. Like, what's the difference between quit and shut down? It just SDL quit. So what? Bruh, really? Oh wait, why it gets... Oh, shut down specific SDL subsystems. Bruh, come on. Come on. Let's just error defer SDL3 shutdown. And let's go here and I guess let's do it here, yep. And what else? So let's set the memory allocation stuff, right? So yeah, let's do it here, main, and let's just use that. So the debug allocator, and we set the memory functions by allocator debug allocator, and detect leaks, panic memory leaks detected. Detect leaks. Why not just de-init it though? That's weird. That's strange. Can't I just like say debug allocator.dinit is equal to dot okay and call it a day? Search, and let's just do this, right? Okay, and I don't think we need this. All right, next up we got the shutdown. All right, cool. Should we try the callbacks? Or nah, let's continue with our mission right now. So we got the shaders loaded right now, which is sick. And here we actually gotta grab the GPA or whatever that is. Let's just call it allocator. So like const, in fact, let's bring this here. Let's say allocator is equal to debug allocator.allocator. There we go, and let's just use the allocator here, and let's pass it here. Next up, so we got the vertex shader and we got the fragment shader. So what's next? We're gonna create that crazy pipeline. Where is that at? Pipeline create info. And create GPU graphics pipeline. you know, let's vibe code this, I guess, and hopefully it would work out just fine. Let's see. So I'm gonna give it my core.zig, and I'm gonna tell it like to translate that part. So GPU fail mode. Translate that, or make a create pipeline helper function, and hopefully it would pick up on my style. Make a create pipeline helper function in Zig. I feel like this is... Nah, I don't think this is great. Get subchain. Nah. Yeah, let's just do it ourselves, bro. Let's just do it ourselves. Alright, fine. Let's go to... So where are we gonna put this function, in fact? Ooh, I guess we're just gonna put it on the core, right? Yeah, let's put it on core. Or should we put it on... No. Yeah, core. Yeah, pretty much. So pubfn create pipeline, and let's see what we got. So here what we're gonna do is yeah, self. We're gonna grab self, and we're gonna return SDL3.gpu.pipeline, right? Yeah, graphics pipeline. And obviously this should be called create graphics pipeline, I guess. Or to be honest with you, for graphics I would just call it create pipeline, and then for compute you could call it create compute pipeline. Yeah. Anyways, now what we're gonna do is we're gonna say SDL3.gpu. Well, actually no, self.device. Yeah. Dot create GPU device. Graphics pipeline. My bad. And here we got a create info. And what we're gonna do here is we're gonna fill out this whole craziness. By the way, does it have some examples here? Wait. No, there's no GPU examples here. So we're just gonna fill this up, right? Or you know what we could do is we could no, that sucks. Yeah, let's just do it ourselves. Fine, whatever. I didn't want to fill out this whole thing, but we just gotta do it apparently. So the vertex shader is a shader. So here actually we gotta use an info struct. Yep. So const pipeline info is equal to a struct, and we're gonna have a vertex shader, which is gonna be of type SDL3 GPU dot shader, and a fragment shader, SDL3.gpu.shader. And what we're gonna do next is dot vertex shader is, so we're gonna grab the info here, so pipeline info, and we're gonna say dot vertex shader and dot fragment shader is equal to info dot fragment shader. And what else? So those already have defaults, interestingly, so that's cool. So let me just copy that SDL thing here. So we're just gonna copy this part so we could keep an eye on it. So what we need here, we need the target info and the primitive type. So the primitive type, Oh yeah, that doesn't work out. So we're gonna say SDL3.gpu.pipeline create info, I guess. Right or no? Nope. How about that? Bro, why everything ZLS? We can't even do comments. My god. Okay, whichever. So comments kind of like messed with ZLS. Oh man. So what's the default here in primitive type, by the way? Does it have like a sensible default or no? Where is that? Yeah, triangle list. So we don't have to set it. So we only need to set the target info, I think now. And what's the target info is? Oh man. Target info is the graphics pipeline target info. Okay, and here we got the color target description, and it's that. So we're gonna say this, I guess, and bro, what? Yeah, let's just say SDL3 GPU dot. No, wait. Color target description. Let's do it here. And the format is the swap chain format. So where are we gonna grab that? I think the window, or there you go. Get swap chain texture format, and we just give it the window. And the blend state, can we just keep it by default? Yeah. Right, so that's all we actually need. That's sick. That's pretty sick. Alright, so is that it? So we're just gonna return this, I think. Or we could say const pipeline is equal to this, try. And finally return the pipeline. And what we're gonna do here, we could just have this and we're good. Alright, so why this is inlined? There we go, sick. So yeah, let's actually try to use this now. So the pipeline, so we're gonna remove this part and we're gonna remove this part, and we're gonna say const pipeline is equal to try core dot create pipeline, and we're gonna do this. Vertex shader is vertex shader and fragment shader is the fragment shader, and we're good to go. So that's sick. And we're gonna say error defer, I guess pipeline.dn. Come on, what? Oh, I guess it's probably self.device or like core.device.destroy pipeline, no? Bro, what? Release pipeline? Oh yeah, there we go. Pipeline. And we gotta do probably the same thing here. Release shader. Yeah, there we go. Fragment shader. And vertex shader. Boom. So is the pipeline getting created properly? And here we go with errors again. So try this, please. And assertion failure. Oh, okay, gotcha. I see what's going on here. So row triangle.frag. And what? Oh, come on. No, it's not this. Yeah, have some other name. A solid color.frag, yep. I was like, bro, what? That gives me, you know, memories. Alright, so let's go. But we have a little problem here, huh? Bro, what the heck is going on here? I think it's probably like memory leaks or whichever. Oh. Well, actually, in this case, in the main function, we're going to say defer. So those are like Vulkan errors because I have the Vulkan validation layer on because I had been using the vk validation, sorry, vk config GY. That's why. So like if you say vk config GY here, right, and I have this on, the validation layers of Vulkan. And pretty much SDL is using Vulkan on Linux, so that's why I got those validation errors telling me that I haven't destroyed those stuff yet of Vulkan. But yeah. Alright, let's try again now that we are actually destroying that stuff properly. And there we go. So right now we're even looking for Vulkan functions, like errors from SDL. But yeah. Alright, so now we got the graphics pipeline. What's next? SDL create GPU graphics pipeline, release the GPU shader, blah blah blah. In fact, it seems like you could just create the shaders, right, like this. Well, also this, and just destroy those shaders once you're created the pipeline. So that's cool. Cool. Next up, let's go to the next thing, which is right now we're doing bind the GPU graphics pipeline, and we're setting the GPU viewport, GPU scissor, and we're drawing GPU primitives. GPU viewport, small viewport. What is that? Small viewport. Where is that? Oh, it's right here. Bro, what? It's hard-coded or? So confusing. Anyways, whichever. Let's go back to our GPU core, I mean. And let's go create a new function in command buffer. Sorry, in frame. And we're gonna call this, I guess, pubfn bind pipeline, maybe. And it's gonna take self frame. And it's gonna return what? I think it will return nothing. Could be an error, maybe. Who knows? We'll see. Self.command buffer dot bind. Well, what? Come on, where's the bind pipeline stuff? Could it be in the pipeline itself? Really? That's kind of annoying. But let's say SDL3.gpu.pipeline. Well, obviously just I mean, we could just pass it by value, to be honest. It's just a pointer. So whichever. It'll be the render pass. Oh yeah. Gotcha. I forgot about that part. Yeah, the render pass. Fine. Let's do SDL3.gpu.renderPass. And we're gonna say render pass dot bind, where is it called? Graphics pipeline, there we go. And here you pass in the graphics pipeline. And we're gonna need graphics pipeline. I mean, we could probably like keep track of the current render pass in the graphics pipeline and call it a day. But we'll see about that later on anyways. So SDL3.gpu.pipeline. Where's the graphics pipeline? There you go. And we're good. Void. Okay, so that this actually doesn't error at all. And so in fact, it's not really a big deal, you know? Yeah, this is not really a big deal. I mean, where's all the stuff that was there? Hold on. Oh yeah, because there's like the other stuff, like, yeah. I see. Yeah, no need for this actually. No need for this, my bad. Let's go back here and here in the render path, we're just gonna say bind graphics pipeline, and here the pipeline. Okay, so where's the pipeline? Well, we gotta do maybe something like this. Can we actually do this? I am not sure. Just maybe. Can we do this in, because we can do that in Rust. Yeah, break BLK pipeline. Break BLK. There we go. So you just like make a label, block, and you say break block pipeline. And that works. Great. And yeah. Now before that, I guess we gotta say render path dot set viewport. And for the set viewport, you're gonna set it to, so minimum depth, max depth is equal to maybe 1. And the region is the region. So do we really have to give it that region manually? Yeah, I guess. Whatever. So let's just say width, and apparently it doesn't have x and y as default, so let's just say y0, and the width is equal to the, where's the frame dot, yeah, frame dot width, and dot h is equal to frame dot height. And also I'm probably gonna put the set viewport in the render path itself, but we'll see about that again. Other than that, we're also gonna set the scissor, I think, maybe. And for the scissor, do we have like the same thing or what? No, this one is irect this time. So irect. So I guess maybe straight up this. You know what? Let me just see what's up. Yeah, so let's just copy this rect. Though I think, well, hold on a second. The height is actually U32 here. So we gotta cast those. So float from inch, frame dot width, and float from inch, frame dot height. So let's add a comma, and let's go. Same thing here. And with this work, expected type found U32. Fine. Int cast. And let's go. Int cast. Alrighty. And use local constant. Wait, did I just remove that? Come on. Render path dot bind pipeline. Pipeline. Sick. But let's try to actually draw using that. So render path draw primitives. And the number of vertices is 3, and one instance 0, 0, and we're good. So we got a triangle, but there is some problem. What? Blind graphics pipeline. Something strange going on here. Yeah, man. So we're just gonna say defer here, right? But here we're gonna say actually error defer. Well, actually, no. Let's remove it. Let's put it outside of this block. Oh boy. Let's go. And finally, we're gonna have a triangle on the screen. Oh my god. That was insane. That was insane. Okay, so should we add this set viewport and set scissor into the render path directly, maybe? Yeah, I think so. We could do that, I guess. So bind graphics pipeline. Yeah, let's actually honestly do that. Let's go here, and after creating the render path, we're just gonna set the viewport and stuff. Instead of frame, we got a self. And let's go. Perfect. And right now, this is the actual code that we have. Alright, so what thing we're gonna go to next? Now that we got a triangle. And by the way, let's start doing git init, git branch dash m main, and what we're gonna do is control B. Where's the GitHub stuff? There we go. Oh boy. Let's add the git ignore. Dot git ignore, and we're gonna ignore dot zig cache. Gonna ignore zig out. We're good to go. Yeah, fine. Let's just commit all this, stage all changes. And so this is our triangle. Commit, and we're good. Now, what's next? Let's see. So where is that GPU examples again? So we got the triangle down. We're gonna do, I guess, maybe the cube next or something like that. Or a mesh, actually. Yeah, we need to do the 3D stuff now. How are we gonna do the 3D? So we probably need a depth buffer or whichever. So I'm not sure which example would really help with that here. Let's see. There is a depth sampler here. There's a blit cube. And there's also basic vertex buffer. Yeah, actually we should add vertex buffers already first. Yep, let's actually start by adding some vertex buffers and stuff. Fine, so we got the Lloyd shader stuff, and yeah, right now the pipeline stuff would go crazy. Yeah, let's go and create GPU buffer, and then create GPU transfer buffer context device. We create an upload command buffer, begin GPU copy pass. Alright, so let's create a buffer, core.zig, and let's see how that would work. So, gonna add another function called fn create buffer. It's gonna take in self and probably some buffer info, I would guess. buffer info, and it's gonna return SDL3.gpu.buffer. Now here we're gonna say const buffer info struct, can't type today, and we'll see what we're gonna need here. So self.device.create buffer. So you got a transfer buffer or a buffer. I'm not sure why they splitted that, but we'll see. And here we just need the size and the usage flags. The size and the usage flags. So create buffer. Okay, so the size would come from here. It's gonna be, well, just that. And for the usage flags, usage. Okay, so what you gonna use it for? Well, we're gonna grab that too. Okay, so usage is SDL3.gpu.usage flags. Let's go, and here we're gonna say info.usage. Cool. And so this is our buffer. Try. And just gonna return the buffer, yeah. Alright, so that's great. Next up, we're gonna basically need to upload the data to these buffers. And for that, let's see how we're gonna do it. So we're kind of just gonna start a command buffer. So we're gonna need the transfer buffer. Right. I guess we could just copy this and say create transfer buffer really quickly. And for that, we're just gonna say transfer usage upload. Wait, no. Upload, yeah. So there's upload and there's doloid, and so transfer buffer usage. Okay. So in our case, it's for upload apparently. And honestly, I think I'm just gonna remove this struct. Really, doesn't really add much. So I'm just gonna say size is U32 and usage is SDL3.gpu.usage flags. So size and the usage here. Now here we're just gonna say create an upload buffer, really call it that, and just call this, it would have a size essentially, and we're good to go. Whoops, what? No, size. And the usage upload. And okay. What's next? We're gonna map the GPU transfer buffer. Should we map it directly? I mean, fine, I guess. So buffer dot, oh, we can't. Alright, fine. We could say try self.device.map transfer buffer. And the transfer buffer here, and the cycle for now I guess false, right? Yep. And what's next? And then you basically nmap it once you're done, once you've written the data. I see. So we're gonna return the buffer here. And why this is... oh, I see. Okay, now after creating the upload buffer, we're gonna upload some stuff. So pubfn upload data self, and you're gonna get some data of type t slice. Right. Where are we gonna put it? I guess maybe here. Data t, and which buffer you're gonna use. So the buffer is SDL3.gpu.buffer, and we'll see. So I guess we're just gonna mem copy this stuff, or yeah, pretty much. Just gonna mem copy mcpy. The destination is... oh, where is that transfer data stuff? Oh, it's given by the map GPU transfer buffer thing. Alright. So const data, and should we return both? You know what? I'm trying to think of how we want to do this. So maybe I'm gonna grab like an array list of slices and then just upload them using one thing. Honestly, I think that's what I'm gonna do, really. So yeah, let's just upload. So instead of doing this, let's just upload data, and instead of getting the size, we're just gonna take the data here, and like you could basically, I guess, give it an array list of slices. So std.array list of slice t, and or I mean, too simply, we could even just get a slice of slices of data. I guess. And we're gonna need this comp time t type. But no, it's gonna be different. Oh boy, well. So what I was trying to do basically is that you would give it like, let's say, the vertex data and also the indices, and then it would like create one transfer buffer, upload them, and you're done. But for that to work, you need to just treat everything as bytes. Yeah, so how are we gonna do that? Is there like a byte thing? I guess UH probably, but or you know what? Maybe I think what I'm gonna do instead, I'm just gonna go the easy route and create like one transfer buffer for now for every buffer. Yeah, and call it a day, at least for now. Later on, we could think about this problem. So anyways, so create GPU transfer buffer, map the transfer buffer, and we're just gonna have some data of type t, comp time t type data, And like after creating the transfer buffer, you're gonna like just destroy it. So we're gonna say self.device dot release buffer, and yeah, that's not like the best, but it should work for now. And here, use of undeclared identifier size. Yeah, for the size, we're gonna grab it from the data. So basically data.len, no? I mean, I think so. Times size of the t, and we're good. But why ZLS suck here? Oh. Let's call this out data or mapped data, fine. And now, yes, it works now, cool. So we're gonna say memcopy to map data. We're gonna put memcopy what? We're gonna ptr cast the data into bytes, I think, and we're gonna memcopy it. And must have a known result type. Let's just try to do this and see what's gonna happen. Anyways, now after memcopying it, we're gonna basically nmap the buffer. So try self.device.nmap the buffer. Buffer, where is that? And we're gonna acquire a GPU command buffer. And we're gonna even begin a GPU copy pass. Okay. So deployed command buffer is equal to self.device.gpu. Whoops. Well, dot create command buffer, right? Or acquire command buffer. And we're gonna try this out. Otherwise, we're gonna like actually, well, no, we can't do that. Man, release the buffer, or I don't think there is like a release command, but you just submit it too simply. Yep, pretty much. So what we're gonna do is self.device.submit the command buffer. No, you just say command buffer. Bruh. Let's just call it command buffer. Let's say command buffer.submit. And could this fail? Definitely. So let's say try. And right now we're gonna acquire GPU command buffer. So yeah, honestly, I'm just gonna make it for one kind of data, and then I'm gonna ask the AI and see if it could like figure out how to do it for multiple data at once, so we have it more efficient. Because using this, we're gonna be making like a command buffer for every single upload, which we don't want. We want to kind of like batch them, but for now we're good. So command buffer.submit. Now begin the GPU copy pass. So the copy pass is well, command buffer.begin copy pass, and we're good. Now what we're gonna do is copy pass dot I guess upload to buffer, right? And here you give it the transfer buffer location. What do you mean transfer buffer location, bruh? Oh yeah, it contains like an offset where you're gonna transfer that data, and we're just gonna have 0 for now, and the transfer buffer, right? And our transfer buffer is sick. And for the destination buffer region, let's see what we got here. The buffer is, well, we gotta create now a regular buffer. Yeah. Next step, we're going to have an offset of 0 and then a size of, well, we're going to have a buffer size. And we're good. Now cycle false, and there we go. So we're gonna have some extra stuff right here. We're gonna say const. So first of all, I'm gonna call this actually a transfer buffer instead. Right. So let's refactor this. And we're gonna create like a buffer in VRAM. Const buffer is equal to cell.create buffer, and the size is whatever is the buffer size, or to simply honestly call it size really. And here the usage depends on the kind of data, so we're just going to get it from the user. So SDL3.gpu.usage flags, and now we're going to grab this size here, call it size, and let's put it here. So const size is equal to this. I'm going to try to create a buffer, and we're good. So now instead of transfer buffer in the destination, we're going to go with buffer, and the buffer size would be just size, and we're good. So after upload to buffer, is there anything else? Yeah, we just end the GPU copy pass, then we submit. So end the GPU copy pass. So like copy pass dot end. Also, I would rather do defer here and just like do something like this, something like this. Oops, there you go. And just have like defer copy pass dot end. And yeah, that's basically it, I think. Right. And this is supposed to give you the final buffer here, not the transfer buffer. In fact, the transfer buffer, we're just gonna remove it. Yeah, there you go. And yeah, all right. So we're gonna generate some vertices. So where's this position color vertex? Position color vertex. I think it's probably in common.h, I would guess, right? Yep. Position color vertex. Oh, I probably need another coffee at this point. Position color vertex. Oh boy. Okay, so here we got like a vic3 float. Yeah, I'll definitely need another coffee because like my brain is just like froze at this point. So I'm gonna be back in a few minutes. All right. Okay, back. Oh yeah, I like coffee. It's my only drug, pretty much. So brewing some coffee. Alright, let's remove this. And where we were. Okay. Map. Okay, let's go. Alright. So yeah, what I wanted is we're gonna make this into Z algebra stuff, right? So we're gonna say const ZA is like import Z algebra, I think, and yeah, and that would give me the other stuff. So now I could grab the vec3s and vec2s, or no need really, we could just use ZA directly. So now we need the position color vertex, or to simply vertex, which is a vec3 and uint h. I'm not sure if we can actually do it. We could probably do that, yeah. So let's say const vertex is equal to a struct, and the so here vec3. Okay, so what is it called? Position, I think. Yeah, and it's gonna be as za.vec3, and for the color, in this case, we're gonna have a uint h. So za.vec, is there like a generic thing that we could use? I believe there is, but generic vector, okay. And the dimensions in our case is 4, I think, yep. And the comp type is UH. And we're good. So that's the position and the color. So what's next? What we're gonna do next is, let's go back to the basic vertex buffer here. How many years will it take to understand and code like this? What if fix? I've been coding on several technologies like for 8 years now as a hobby, but like I've been all over the place. So I've been into game dev, I've been into Roblox. I actually started with Roblox. I've been into Godot, into Unity, Unreal, Vulkan, whatever, you name it, I probably tried. It's like Rust, you know, Zig, a bit of JavaScript. Yeah, I've been all over the place, so I'm kind of like a generalist, but yeah. And welcome to the live stream. But it doesn't really, it's not much. I mean, you see my whole process. I'm still like struggling and everything's like, it's nothing to do with much with skill, you know. But yeah, anyways, this is set up to match the vertex shader layout. Vertex input states, so number of vertex buffer is 1, and vertex buffer descriptions. Now I'd like to freaking like copy this, but it just wouldn't let me. The pitch, and here number of vertex. Or you know what I could do? Let's just grab this part and let's create a new file here really quickly, and there we go. So that's cool. So let's go back to our core.zig and let's add some stuff into the pipeline. So first of all, I think one thing that I'd like to add to the pipeline though is maybe you could just like give it the shader info directly. Or actually maybe not. No, never mind. So we're fine. Next up, what we're gonna do here is not in target info. We're gonna have like a vertex layout thing, I guess. So vertex input state, is it, or what? Yeah, it is vertex input stage. And here you say from like vertex attributes and vertex buffer descriptions. So let's start there, I guess. And what this takes. Come on. Man, I hate this. Vertex input stage. So it takes location, buffer slot, blah blah blah. Really, you know what I'm gonna do here is just SDL3.GPU vertex input stage. Okay, let's see. So we're gonna need the vertex buffer descriptions, which is basically SDL3.GPU vertex buffer description. Though it should be like this, I guess. Alright, and let's go comma, and the comma here, because this is getting insane. There we go, and now we could fill this up. So we're gonna go with the vertex here for the rate, and the instance step rate is 0. What's the default of this, by the way? It doesn't have a default. Okay, sick. And the slot and the pitch. So the slot, obviously it's gonna be 0, and the pitch would be the size of the vertex, right? So let's just grab the vertex type for now, right? For now. I'm not sure how we're gonna do this later on, but for now let's just grab the comp time t, or like vertex type, and let's do this, and we're gonna say size of vertex. Anyways, what's next? So let's look into the next thing, which is the vertex attributes here. Now for the vertex attributes, you're gonna go with again, it needs like a slice apparently, so that's cool. Next up, oh boy. So what we're gonna do here, SDL3.GPU vertex attribute, and let's go. Now the buffer slot probably 0. The format is the vertex format, and in our case, which format we're gonna go with? The U-byte4 norm. Really? Oh, so like we're gonna have like a buffer attribute for each one. Gotcha. So for this one, we're gonna go with float. Oh, what? So F32, I guess X3. That's probably what we need here. The location is equal to 0, and the offset is equal to 0. Or should we hard code the vertex type, maybe? Honestly, to keep this simple, I guess I'm just gonna hard code that type for now. And we should be good to go now. This gotta be ZA. We'll see later how we can deal with that stuff. Maybe like have some sort of like an interface for a vertex or whatever. So great. Now size of vertex, and here we got like F32 X3, and then we're gonna have another binding which have probably buffer slot 0, right? And the location 1. And the offset is, well, I guess offset of the vertex. The field name is, in our case, color. Or we could like even do some, you know, zig comp time stuff to generate this vertex attributes. But that's too much for now. So here we're gonna need unorm. Oh yeah, UH. So UH x4, maybe normalized. I don't know. Is that like norm is normalized, or what is normalized anyways? What is normalized in Vulkan formats? Yeah, normalized, I think it's like floats or something. I don't remember. Oh yeah, I see. Gotcha. Gotcha. But like, is this format normalized one or no? Is this normalized? Okay. So basically we just store like a UH, but the shader sees it as a float. At least that's what I understood. Either way, next up, so that's the offset of color, and here the offset of position. And we're good to go. Alright, so what's next? I think that's it, I guess. Let's go back into the examples here, and yeah, I mean, I guess that it. Flow 3. Yep. Alright, so now what's next? So we're gonna create some, yeah, vertices right now. Alright, so we're gonna create some vertices. Well. How I'm gonna do this? Let's ask ChatGPT to generate some vertices really quick. But, well, honestly, let's go with Gemini so I could feed it the source code really quickly. And let's just grab this to give it the context. Oh, bruh. Come on. Now let's give it our core.zig. Now make an array of vertices. Main.zig. There we go. So we're just gonna grab, I guess, this and upload the data. So right now that we have wrote some code, we could rely on the AI more because it have more context on my style of coding. Find the vertex buffer and stuff. Alright, so let's go back to the main.zig, right? And what we're gonna do is here, we're gonna do this stuff. So did they get it right or no? I guess let's find out. So let's grab that, what is it called? ZA, where's ZA? Pretty sure I had it here, what the heck? Yeah, let's put it on top there. And let's actually just make it public. Really, yeah. Let's make it public, and let's come here and say const za is equal to core.za. And we're good. So now what we're gonna do? Yeah, it should be working now. There you go. Look at that. Lovely. And it just used our upload data function. It uploaded the vertices and usage vertex buffer. Perfection. Core.device.release the buffer, and we're good. Now here we're just gonna bind the vertex buffers. There we go. Sick. And let's try if this works. Oops. Vertex is not marked public. Yeah. Okay, let's just really quickly say public. Can we just say okay, let's just try to say var here. And expected type U32 found U size. What? So create buffer expecting, I see. So then what we're gonna do is just as U32 or like int cast. I don't know, let's try this. Nope. Fine, let's just say int cast. Right, and this gotta be U32. And we're good. Expected found GPU transfer buffer. Let's see. Release transfer buffer here. Core vertex doesn't course into element of type UH. Let's see how it's going to cast it. So just use slice as bytes. Given a slice, return a slice of the underlying bytes. Okay, so that's how you basically get a slice of bytes. Next. Expected error union type found, whichever that is. So let's remove the try here. I guess it's working. Really. But I don't think we're using the right shaders. Hold on. Where's the shaders? Position color. Let's use the position color shader now. I'm not sure why that even worked, to be honest with you. So let's see. And yeah, it seems to be working just fine. Somehow. Alright, so what are we gonna do next? Yeah, right now, you know what I want to work on? I want to think about how we're gonna deal with the vertex attributes, and also how we're gonna deal with multiple data. Like, yeah, let's try to add, for example, index buffer. So now this, I mean, we could make another, like, just say upload data again, and it would just work out just fine. But like every time we try to upload data, we're creating a new transfer buffer, a new command buffer, which is very wasteful. So what we're gonna do instead, we're gonna ask it to, can you make this work with multiple data slices? So we upload in batches, like for example both vertices and indices. Let's see if it's gonna do a good job or not. Let's see what's the idea. Oh, whoops, not here, not ChatGPT. Wait. Not this. Let's go back to Gemini. It's the one that have the context. Okay, so we could have took way less time by not making this abstraction, but I'm actually making a library right now to abstract out all the boilerplate codes. So when we create like SDL3 GPU applications, we don't have to touch all this boilerplate crap. You know, it just works. So yeah. And why this is taking too long, bro? Yeah, that's taking forever. Let's try again. Yeah, this is not working. Okay, let's try Claude while this is loading. Oh, it also includes the usage for each one. That's sick. Oh yeah, and we also gonna need to create GPU buffers for each one. That's perfect. Yeah. Type the helper to make call sites cleaner. What? Okay. Oh, I see. I mean, let's see if this works. So let's just like add this changes and call this vertex buffer. All right, apply data. So instead of this, you're gonna have this deployed buffers. And now we're gonna use it like this. And let's see what's gonna happen there. Is it actually taking into account the offsets and so on? Or what it's doing exactly? Don't tell me it's like, wait. Yeah, it does take into account the, great, perfect, that's exactly what I want. So now how are we gonna do this? I mean, in fact, you could have just like made one buffer for all of them. Even like in the GPU. I mean, right now it's using one transfer buffer, but it's creating multiple buffers for each one in the GPU. I mean, we do lose out on the usages flags, but I'm not sure what it's gonna do for that. Where's the usage flag? So it's creating one buffer, great, and the usage is taking it from the caller. Okay. Oh, there we go. So here you just say vertex and index, and then it gives you back one buffer but like multiple offsets. Yeah, that's sick. Is merging the flags fine, and we won't have any alignment problems. This. Either way, which you think is the better idea? One one buffer or multiple? Yeah, some alignment problems and so on, so we're just gonna stick to this. Yeah, alright, fine. Yeah, at that point we need a proper GPU memory allocator. Yep. Okay, let's continue. So, that should transfer. All right, so we're fine with this way. So, where we were again? My God. Yeah, let's actually copy, as I said, the calls that we have here, right? And let's just say, instead of this, we're gonna have this, and instead of context, we're gonna say core, the upload buffers, and here core, I guess, dot make upload or something. No. Oh, core dot make upload like this. Okay. Now here, use of undeclared identifier. In our case, it's core.vertex, and for now, we're not going to be having any index stuff. And here we're going to say a core allocator.free maybe, or just choose simply core.free, like allocator.free, and free the results. Right, and then we got a vertex buffer here. Sick. Alright, let's try this out. Right, local variable is never mutated. Sure, I guess. Consider using constant. Array literal requires address of operator. Sure, because we have like an array and we need to course it into a slice. The fact that it still works kind of like makes me what? But yeah, it does work. Alright. And we need to make sure to like destroy all the buffers that we have. Alright, so let's actually rename this into buffers. And we're gonna add some indices now. Now for the vertices, we're just gonna say, I guess, const indices is equal to, I guess, u16, or yeah, like this, and u32 actually. And let's go with just 0, 1, 2, and that's the indices. And now we're just gonna do this, and let's just go with u32, and in the C's index is equal to true. So you can see right now we're using one single command buffer and transfer buffer to do all the uploads that we have, which is amazing. Next up, very efficient. Now that we got the vertex buffer, next is the index buffer, and the index buffer is buffers1. Sick, and now we're gonna basically bind that. So bind index buffer, and here dot buffer is the index buffer, and the offset is 0, and the index element size is indices 32-bit, and let's just add a semicolon there, and we're good to go. Lovely. Lovely, lovely. And is there anything else? Yeah, instead of draw primitives, I guess we gotta maybe do something else now. Draw indexed primitives. Yep, so the number of indices is, well, indices.len. Instances 1, 0, vertex offset, I guess 0, first instance 0. same problem. And boom. That's cool. Love that. So now let's try to make some, or that's fine. That's fine. All right. So what we can do next, should we try to maybe auto-generate the vertex attributes using comp time? Or should we just probably go right now straight to, yeah, let's just go straight to the depth buffer and stuff like that. All right, sure, let's go to the depth buffer. Where's the depth buffer? SDL, well, let's see. So we got a vertex buffer and an index buffer, perfect. That's all that we have in here. Next. Basic triangle, basic stencil, blit cube. What is blit here? What it means, blit? Oh, they have a skybox. Ooh. Oh. That's pretty sick. Create a GPU texture. Oh yeah, we also have to work with textures and GPU samplers. And what's next? NAB GPU transfer buffer. Yeah, I guess this is probably just making a skybox, really, which is insane. We could go back to this in a second. Definitely. Anyways, let's go to the next thing, I guess. Clear 3D slice, clear screen multi-window, compress textures, cube map. Probably what we want is depth sampler. Instanced, indexed. We could also go for textured quad, but nah, let's go to 3D directly. Okay, so where's that depth buffer stuff? So it's right here. We gotta add this depth stencil stage, and what else? Rasterizer stage. Flow 3 bytes. And now they're here, they're using position texture vertex, so that's cool. And here we got SDL, create GPU texture for the scene color. Wait, what? Are they making like some sort of outline shader or whatever? Cause what the heck is this? Deploy to the GPU buffer. Where they're creating the depth texture, or does SDL already does that for us? Like, you know what? Let's ask Gemini. This example is about it's so slow, bro. Yeah, it's so slow. Let's go back to here. What this example is about. Yeah, outline edge detection using a 2-pass rendering technique. Interesting. How do I add a regular depth buffer to my app? Yeah, there we go. Create the depth texture, update your pipeline to enable depth testing, and pass it into your render pass. Sure. So let's create a helper function, or actually let it do that. Yeah, let's vibe code it hopefully. Add the required helper functions. Okay, so we're gonna copy this create depth texture. So as you can see right now, since we have a bit of code already set up right now, the AI is more helpful because they have some context of the style and the binding, etc. So that's pretty cool. Let's just go ahead and do this. So pubfn render pass. Where's the pubfn render pass? There you go. So right now we're gonna add some code for the depth buffer too. So essentially we get a depth texture, and if we get one, then we got some depth info. Cycle true. That's interesting. I gotta check on that later on, but for now we're fine. Then it begins the render pass, and if depth info, then it passes that. Alright, anyways, let's just see. And update create pipeline. So fine, let's add this. Where's the pipeline info? And let's just copy this create pipeline function. Now I'm just going to create a depth texture. Say depth test is equal to true here. And in the render pass path the depth texture, too simply. Yeah. So let's come here and let's do const depth texture core dot create depth texture, and here the width. Now the width in our case, let's just hard code it for now to 800 and 600, though later on we gotta figure out a way to resize and stuff. Next up, we just like use that. First of all, the pipeline, we gotta add dot depth test is equal to true, and the render pass, gotta add the depth texture. Is that right? I mean, yeah, but I'm not sure why it's not. Or maybe, no, that's good. So that's weird. Let's just try to actually run this and see for ourselves. Expected 3 arguments found 2. Oh, core. No field name type instructs. Really? So there is like a texture type here though. And it's by default 2-dimensional, so we're fine here at least. And here the sample count And yeah, no multi-sampling for now. D16 U norm. So depth 16 U norm. Let's go. No field named compare OP. Really? So what field there is here? Vacay dot depth stencil. Oh well, not vacay. SDL3.GPU dot depth stencil state and compare. So yeah, just called compare here. So apparently it seems like the binding is really like handwritten binding. It seems to me, which is insane. Like, bro. I mean, amazing. Wow. Anyways. No field named has depth stencil target in graphics pipeline target info. What? So target info in create pipeline. So this is vacay dot, oh well, man, come on. Dot target info. Graphics, no, graphics target info. But why it's not showing me anything here? What the heck? Bro. There's just like a depth stencil format and that's all. Yeah, so there's nothing like that. Next. Again, depth 16U norm, else invalid, whatever that is, and known member named invalid. I don't know. Whoops. Oh man. Where I was now. There we go. So what's that other one called? Indefined or whatever. I can't find it here. Which is strange. Well, else null, yeah. Next, no field named load OP, so it's probably just Lloyd and store. And probably stencil Lloyd and stencil store, so just remove the OPs. Expected type GPU depth found const. And finally, my god. Alright, so I guess maybe we have done it. Right now, let's see how we could do 3D. But first of all, let's make sure that we are destroying this depth buffer. So like, where is the depth buffer here? Or depth texture? So we're gonna say defer depth texture dot, well, actually core dot device dot destroy, or like release texture. And here the depth texture. And there we go. So what's next? Is there anything we're missing so far? So right now we need to make sure that when we resize, we actually resize the depth buffer too. Okay, so what are these errors about? Oh yeah, gotcha. So let's just do that. So before we free the array, where's the upload? Here we go. So before we free the array, we free the buffers inside of it. So like core.device.release buffer. Too simply. And we're good. So perfect. So right now we got no errors, I think. Yep, pretty much. So that's lovely. So this is the depth buffer, but let's see how we could resize this. Resize depth texture on resize. Where's that? There you go. It's taking a long time for some reason, huh? Is there something with the network or what, bruh? Network is fine. So something maybe is wrong with Claude? Bruh. Yeah, Claude. Alright. Let's go back to Gemini here. And resize depth texture on window resize. Let's see what it's gonna do. Oh yeah, so let's just base our code on this. Window resized with use of undeclared with. Really? Undeclared with. Oh yeah, we declare it here. Gotcha. So like core, I guess, dot window dot get width, I guess, or like size in pixels. Ah, there you go. Try, and this is just like the window size, and we could just say that the var width is equal to window size dot 0, and here window size dot 1, and it should be int casted to u32. I think, isn't that the case? No? It's i32 actually. i32. Okay. i32. So let's go with i32, I guess. Oh man. Int cast this. Now the window size is never mutated. Let's call this const, and we're good to go. So now we're gonna be using this width and height. Width and height. Now obviously we should make like a function in core that gets the size directly. Right now just getting this to work really quickly. And here we set the width to ev.width without the int cast. Same thing here, and recreate the depth texture. So we release the old one, and then we create a new one. And we're good. So now if we do zig build run, expected type U32 found I32. Yep, gotcha. So yeah, gotta do int cast every time, which kind of suck actually. You know what, fine, let's just say U32 and U32 here, and instead use int cast here, because I don't want to keep on doing that every single time we try to use the width and height. Cannot assign to constant. Yeah, var, and let's go. All right, now hopefully we could just resize. Yeah, perfect, love that. And we're good to go. I'm just gonna remove this branch, and we're gonna like do this, and we're gonna say this is like the depth texture, and commit. We're good. Now let's actually publish this repo, why not, already, just in case something weird happens and maybe my computer breaks or whatever. We don't want to lose all this progress. So yeah, and here's the actual code, there's the link, and we're gonna add a little license really quickly. License, choose a license template, MIT license, review and submit. Commit changes, and we added a license. What's next? Yeah, that's fine. So can we just fetch this? I forgot, how do you fetch this stuff? I guess like this, and sync changes. Alright, so there we go. Okay, so what are we gonna do next? Now that we got the depth texture ready, I think we should work on a cube already. So what I'm gonna do, I'm gonna tell the AI to generate for me some cube stuff, some cube vertices. Let's go to Claude. I guess it's probably broken, I guess. Can you guys confirm that? Is Claude like out of service now? Probably. Anyways, generate cube vertices / indices. Yeah, I think Claude is out of service probably at this point. Generating a cube manually can be a bit of headache. Okay, so in your main.zig or helper function. Oh, I see what it's trying to do there. Nah. Let's keep it simple for now. Let's just grab this. And right now we got a cube, but we need to somehow to rotate this. Alright, so now how we're gonna, yeah, exactly, so the car exists, you know? Yes. Claude has recent activity on down the texture. Yeah, apparently Claude has been down. Yeah. Alright, so this is position color.verge. I think maybe we should just work on a texture first already. Yeah, honestly, I think I'm gonna work on a texture first. Yeah, let's go ahead and do that, bruh. Let's go back to a triangle. Or we could keep it this way, fine, whichever. Which concepts that matter more than graphics APIs and graphics programming? I mean, everything. So I'm not sure, like, in which aspects can you be more specific, like, on what you're curious about? Because that's a very broad question. Like, I could list a lot of stuff there. There's like the math. There's you should understand how you do render passes, like multiple passes, for example, to do, let's say, deferred rendering or whatever. Honestly, I've never touched that, at least not yet, but we'll see. Anyways, so now what we got? All right, so we gotta try to use textures now. Let's try to make textures. Map, DSA, design patterns. Yeah, pretty much the regular stuff. Okay, so the math and the render loop. Or should we just try to go to the... You know what I'm gonna do, actually? I'm gonna do something quite interesting. I'm gonna go to my Kodochaku Zig VK that we worked on, and I'm gonna go to SRC. I actually forgot about this. And camera.zig, and we're gonna steal this code and adapt it for our camera and call it a day. There we go. Oh boy, let's go. Let's grab this and let's see what we're gonna need. So camera.zig, and boom. And but wait, no, this is not gonna work because this is using the raw binding. I mean, we could probably just like use, you know, SDL3.c, but I wonder if that would work out just fine or not. We also have some vk extend 2D stuff. Let's remove vk here, Vulkan. And now instead of extend, we should have something else here. Should we use this or no? Yeah, it seems good. So let's just make use of SDL. Like, let's just grab, I guess, a vector. How about that? ZA Vic2, I think. And here, instead of float from int, we're just gonna say stench dodge. Is it like X and Y? Yeah. And there we go. And I think we don't need this either. Same thing here. Yeah, I think this should work. This should work. And then later on we could try to like refactor it into the binding. And we're good. So where do we even start here? Where do we even start? We're gonna need like a uniform buffer. And well, let's create a camera first of all. So const camera. Is equal to, well, import camera, so probably camera.image or something. Const camera import. Well, camera.zig. And here, let's see what we got. So .init. Here, like the eye, the target, and the up vector. You know, let me go to my source code where we're using the camera. So main.zig or like app.zig, yeah. Where's that? Where's that? There we go. let's see where we're using the camera.init, and here we go. Let's grab this, copy it over, paste it here, and we're good to go. Now let's just say za.vec3, za, and we're good. Okay, so we got a camera now. Now we're gonna upload that camera. So how are we gonna do that? Well, so probably core.make upload, and now instead of the core.vertex, we're gonna say camera, and the data would be a slice where you only have one camera. Actually, not camera, matrix 4, my bad. So we're gonna have like a za.matrix 4, and here we're gonna have, what is it called? Yeah, our camera. So like camera dot, wait, why this is not giving me? That's strange. Can we say uniform here? Bro, what? What? Is there like a special uniform? What? How do they do the uniform buffer? Uniform. Compute uniforms. Wait, what? Where's the uniforms? Or maybe you don't have to like create a buffer for uniforms, or what? No way. I'm so confused. Oh. Create compute. What? Oh yeah. Push GPU compute uniform data. Okay, so you don't create like a buffer in SDL, you just push it. Ah yes, yeah, that's cool, love that, oh my god. That makes it way easier. Alright, so let's remove this part, and let's just go ahead and say, where is that? So where we should do that, push GPU, okay. Let's do it for example here, I guess. And let's just say, render pass.push, no? Bro, what? I'm confusion right now. Bruh. Then where could it be? Can we go to SDL3 GPU? Or you know what? Let's ask the AI. Did they actually tell us here? Command buffer. Oh, really? So like frame.commandBuffer.push. Oh, there you go. Push fragment uniform data and push vertex. In our case, we probably want you in the vertex. And the slot index, I guess let's say 0 maybe. And the data here, we should use that thing that we've done there. I guess mem as slice or something. Bytes as slice, I guess, or slices bytes. Yeah, a slice is bytes. And then we should give it the camera dot get projection, get descriptor matrix. And here it's, wait. It needs a generic vector F32. What is even that? Extend za.vec2. Okay. So let's give it that. Why not? Let's say .new, or like I guess za.vec2.new. And let's give it the width essentially, which is a U32. So we gotta say float from inch width, comma, float from inch height. And let's see what's gonna happen here. Wait. Axis of union field while field struct is active. That's strange. Can we just grab this part? Or like, let's grab this part. And let's say that this is the data. And there we go. And now this is the matrix is this. Now call that comp time here. I mean, how did we use this here? Yeah, slices bytes. Yeah, and just give it the data. Oh, I think. Yeah. Gotcha. Gotta give it a slice here. Expected pointer slice array found. Okay, but which line is triggering this? Here. Found const struct. Can we say maybe var? No. You know what? Let's do this. Do this. And do this. That's strange, but whatever. Whichever floats your boat. Oh, LVM image. Love that. Alright, next up. Oh, if you're only sending single objects, std.mem as bytes is more semantic. Yeah, perfect. Love that. Let's go. So let's just replace, I guess, this with this. And we're good to go. And I think it's probably the same thing now. I just didn't know that there's also std.mem as bytes for single objects instead of slices. So that's cool. Next up, what we're gonna do is we're gonna use that matrix. Remind me, why are you using an older SIG version? I mean, it's the latest stable version though. 0.15.2. Do you mean something else or what? Like 0.16 still haven't been released yet. Unless if it got released yesterday or something, I don't know, then so LVM Zig is in nightly. No, I actually have like enabled LLVM myself, because like the latest GCC in my Arch Linux, so basically it's a rolling release, which means I got the bleeding edge one. It had like a regression of some like linker stuff. I don't know, or I don't remember, like S-frame or something like that. And I just had to basically fall back into the LLVM compiler. Use that. It's a bit slower, but it works for now, at least until they fix it. But yeah, alright, so now that we got this, what are we gonna do? I think we gotta change right now the shaders to use this. Okay, so Let's go to the shaders. Oh my god, we gotta have to like compile shaders or stuff. My god, is there like already some shaders for us here by any chance? Okay. Or you know what, we could also possibly steal the, oh, we already have a script here to compile stuff. Love that, but we need shader cross. Yeah, so let's grab our shader cross. So for that, we're gonna go to, where is shader cross? There we go. And currently there's no releases, but if you go to, let me remember how this works. I guess actions. Yep, actions, and they have some actions here for building it. And you could probably just go to build here maybe, or like, yeah, just go here, the latest one, and then just grab your shader cross depending on the version. I don't think it got added into Arch Linux yet, nor the AUR. But anyways, let's just grab the Linux version here. And we should be good to go. Now we're gonna like extract this here. And where is that now? Hold on a second, I'm gonna come back. Okay, back. Alright, so we installed this, and where is it now? It was in the zip, right? And we probably need to extract it again. And there you go. So there's like the bin here, and here we go. So I'm not sure how do you add it again in the fish shell into the path. So what we're gonna do, let's see how to add this path to fish shell, in fish shell. Whatever. And now if I restart this, there we go. And I have shader cross now. Perfect. Now I could actually use this compile sh. The not so great thing about this though is that it's every time I'm gonna do a compilation, it's gonna compile all the shaders that are inside of there. So you know what we actually gonna do instead? We're just gonna compile our own, I guess. Yeah, we're just gonna make a little file of our own here. So let's see what kind of shaders we have here really quickly. We got fill texture, blah blah, Verge, Skybox. They're all in HLSL apparently. There is a textured quad. Color, yeah, there is ones with matrix. Okay, so that's one is interesting. So textured quad. So there is no position, I guess. Wait. Position, color, instance, and transform. There is transform. Maybe this is what we need actually right now. Hold on a second. So yeah, there is a UBO here of float4x4, which is like a matrix. Although I haven't really never dealt with HLSL before, but this is pretty self-descriptive, I guess. Yeah. So that should work actually. We should probably just use this instead. Yeah. So you know what? Let's copy this file name. Or let's just type it. So let's go back here. And instead of position color, bruh, come on, where is it? Position color transform. Okay, and let's zig build run. Alrighty, I guess we're gonna need to add some stuff into the pipeline. Yeah, I think so. Maybe. Let's see what we got here. So this is like the Vulkan validation stuff from SDL. Yeah. So how are we gonna add that? Well, we gotta change in pipeline to add the push matrix. Oh, gotcha, bro. I forgot about that. So let's go to the shader here, and we're gonna add. So here we got sampler count, storage buffer count, storage texture count, and uniform buffer count. We're gonna go with uniform buffer 1, and let's go. Oh, let's go! It works. It works. It works. Love that. Absolutely love that. So we're actually using our camera. Right now we could just add that that stuff. Alright, so let's steal the code from Kodochaku Zigveke. Let's see how we're doing the DT calculation again. So there we go. So we just do something like this. So let's grab that code and let's go to the where are we gonna run this? I guess we could run it before the begin frame. Why not? And let's go. Okay, so now instead of c.sdl get ticks, we're gonna do how the heck do you do ticks, bro? So get millisecond since init. I think. Though there was a frame capper extra. Does that give us the DT by any chance? So we don't have to do it? Where's the extras? The extras.zig. And there is DT here. Okay, so maybe we could use the frame rate capper to calculate dt really quickly here. Oh, run at unlimited FPS. Okay, so that's exactly what I want here. So, okay, I guess maybe let's try to use that. So we don't have to calculate it on our own. And I wonder how the calculations... Yeah. Wait. Where dt is being used here? No, this is not gonna work. Never mind. never mind. So, what are we gonna do here? Milliseconds since init. But in fact, we could just maybe say get seconds since init. Can we do that? No, there's only gets milliseconds since init. Okay, fine. And what we're gonna do next is current ticks, comma self.start ticks. So let's just gonna have start ticks here, and we're gonna say, kind of copy this and say this is the start. Whoops, start ticks. And what else? Start ticks is equal to the current ticks and camera.update dt. And that's basically it. Now, yep, var. Long stream today, just hit the 4-hour mark. Yeah, we're gonna try to hopefully go like basically match all the stuff that we had in the Vulkan stream in this stream. Hopefully, we'll see. We probably can do it. It's just like the start. We're currently making like an abstraction over SDL3 GPU to make it like the core abstraction, which is taking too much time. And also the fact that we're using like an other binding, which is also kind of slowing us down because we're also exploring that. And yeah, there's just a lot of stuff going on. Anyways, so the camera, where's the camera? Var camera. What is going on here? That's oh yeah, we don't actually give it the events. I forgot about that part. Okay, so how are we gonna do that? Yeah, we're gonna come here and say camera the on event. And here, whoops, event dot. Okay, so now we're gonna figure out how we can extract the raw bindings. So the window core dot window, I guess dot value. There you go. And here event dot. Does it not give me the event, please? I really don't want to bother with like translating that code now. Is there a way to actually convert into raw event? There is from SDL and probably to SDL, right? So let's see, to SDL. Oh boy, let's go. That's nice. But wait, this gives us a union SDL event, and this is expecting, yeah, I guess that's probably it. But what's going on here? Something strange. Yeah, we just need this. And let's go, but what's happening here, bruh? Come on. There you go. I mean, it kind of works. The input, for whichever reason, is inverted from Vulkan. I'm not sure why. And those colors looks weird. But yeah, it works. It really does. But let me see what's wrong with this. Wait. Yeah, it's inverted. Alright, so let's try something. I'm not sure like about the SDL coordinate space. Is it like Vulkan or what exactly? I mean, it's using Vulkan under the hood at this point, but let's go back to camera.zig. What if well, what is it called? Okay, so like I had some code which kind of flips something. There you go. What if I remove this? Bro, what? Yeah, now it works. So we don't need that hack. It already works with the... Yeah, lovely. So it's probably like OpenGL, I would guess. And oh, are we not calling? We're probably not calling. But yeah, it works. That's insane. Alright, so what are we gonna do now? Let's change here the... Let's make it black. Maybe let's say 30. 30, because that sucks. That color sucks. Oh, that's not as dark as I thought it would be. Oh yeah, I know why. I always forget. So this is actually floats from 0 to 1. That's why. Not like... Oh, man. Okay. So 0.1, 0.1, 0.1. If someone have an HDR display, they're done for with that number. Alright, so that works. Love that. So here we just like added what? We added the camera. We added the camera. Pretty much. And a cube, obviously. So yeah, that's it. Oh wait, cancel. Commit. Sync changes. Okay. Alright, so we got a camera. Although it would be better to actually like translate that camera.zig into like the zig binding. But as you can see, the SDL to raw SDL conversion works just fine. So that was sick. Love that. Absolutely love that. So we're not boxed in. So that's cool. Let's just remove this. So what should we work on next? Yeah, let's work on the object loading. But for that, I think we're gonna grab our mesh.zig. Like we're gonna make like an abstraction mesh.zig or something. Yeah, so it's gonna contain like a vertex buffer, index buffer. And we're just gonna steal this code. Yep, I think that's what we're gonna do next. And then we could like add a texture. Yep. All right, let's do that. Or you know, we could ask the AI. Is Claude on again? Is Claude back? Yeah, I don't think it's back. All right, never mind. Extract mesh.zig from that code. Let's go. And Claude will return suit. Claude is currently experiencing temporary service disruption. abstraction, the mesh logic into its own file is the smart moves. It's going to contain a vertex buffer, an index buffer, and a cube. And yeah, that works. Sure. I love this already, actually. Love this already. It's at least less intimidating than Vulkan, because what the heck was that, bro? Oh, man. And like, you stay with SDL code instead of having to worry about like multiple things at once. Anyways, so that's the init cube. Index count, indices, so make upload. As you can see here, it's using that make upload thing. Lovely. And it's taking core. Hey man, I've been working on a Zig based project for a month now. It's open source. Mind giving it a look? Sure. Hello NZ, welcome to the live stream. If you guys ever have like any projects that you want me to look into in the stream, then please, you can join my Discord and put the link there. Do you have Discord? Hopefully you can find the link down in the description below. Or just put it in the chat if you can. Probably wouldn't let you, I guess. But yeah. Alright, what we're gonna do now is like const mesh. My username is Legation Pro Zigzag. What it's about? In short, what this does, I have performance SIG-based tool, generate comprehensive markdown reports of source code directories, parallel smart binary file detection. Oh, could this be like useful for the AIs? Like you would copy, like you would use this to generate a report for the whole like folder and it would just work? Like you can just copy that whole report into the AI? Is that it? Am I getting this right? I mean, that's very interesting. That's very interesting. What Zig version it's using? Yeah, that looks very sick. Though I'll have to try off camera first. And maybe next stream we could, or even in fact, maybe I could even make a video about it. Yeah, it would be better if I just make a video about it, because this is pretty interesting idea. I love that. If I understand this right, this is very useful for our case, for like AI, for example. You would just generate a whole report of a repo and just copy it over without needing MCP and all that business. But yeah, congrats. I'll see about it off camera, and if it works for me, I'll probably make a video about it. Yeah. So yeah. Okay, so for now, let's just focus back on what we were doing. yeah, it's a very good. I was actually searching for such a tool before, but surprisingly I couldn't find much. There was some tools, but I wasn't very like, I don't know. I don't remember honestly what happened. Like there was some Node.js tools I think that I found or something. I don't really remember what happened there, but yeah. Anyways, let's just go back to business. But yeah, for cube mesh, yeah, that would be very useful for my streams. So, all right, where we were. Okay, so currently we have all this weird vertices and indices and and buffers and stuff. So instead of this, I think we could probably just do this. Boom. Init cube, and it just makes the vertices, the indices, and the buffers, and boom. Oh my, I really love this, man. Really love this. But wait. Oh, it's just storing the index buffer. Yeah, that's good. That's great. And yeah, I love that, man. How about the bind index? Yep, that's pretty sick. Okay, so let's actually use this. Bind graphics pipeline, bind index, bind vertex. So let's remove this part. And let's come here. And let's do a mesh draw. But yeah, if anybody else is watching this stream, just know that if you have some project like you would need more reach, then please just reach out to me. If it makes sense to me, I'll definitely try to cover it in some video or stream. But yeah, draw. Okay, so that seems good. All right, and there we go. So right now we have a mesh abstraction. That's pretty sick. Bind the graphics pipeline, get the description matrix, and we're good. All right, so what we're gonna do next now? What we gonna do next? Yeah, let's add the textures now. Let's figure out how we're gonna add textures. So where do we even start with that? So there's like a textured quad here. Okay, point clam, point wrap. Let's feed it to the AI. What we need to add textures inspired from that C code. Yeah, we're gonna have a create texture which takes width and height. This allows it to be used in shaders. Yeah, and then we're gonna create a sampler, and then obviously we're gonna add the UV. In fact, we're gonna remove color and just add the UV there. Now each vertex needs a UV coordinate. For a cube, each face usually maps from 0 to 1. Okay, the shader metadata, textured quad.frag. You must notify that you are using the sampler. If you miss this, okay. Binding in the render loop in your main.zig. I really love how easy you could like add samplers and uniform buffers and all sorts of stuff in SDL3 GPU. Like, cause in Vulkan, oh my god. You're in big trouble. Binding in the render loop. Yeah, okay, and now bind the texture and sampler to fragment slot 0. Sick. Sick. So for that, first of all, let me clean up this mess, because oh my god, this is too much. let's leave this. I mean, let's remove this. Let's remove this. Okay, so that's fine now. We don't need this either. Okay. So let's add this pubf and create texture, I guess. I mean, you know, let me give it the zig that we have right now, just to make sure that it have it. So this is core.zig, add the helpers needed. Okay. Bruh. Wait, if we go to common.h, where's common dot? There we go. And what vertex it's using again? It's probably using position texture vertex. So let me just give it that. Here is common.h. By the way, because as you can see here, it's getting it wrong. It's thinking that it still have a color here. So here's common.h. Wait, what the heck? No. Just remove color component. Replace it with UV. Okay, let's go. Okay, welcome Anze. Updated core.zig. So yeah, let's grab this UV here real quick. Where's the vertex? Vertex. Oh, well, yeah, we put it here, I think. No? Wait, what? No, core. There we go. So instead of color, we're gonna have now a UV. And then that means we gotta change some stuff. Like here, instead of this, you're gonna be using F32, I think, right? Yeah, X2. And instead of color, we're gonna be using UV. And there we go. What's next? Is there anything else? Yeah, I think we're good from that part. And here we're gonna have like create texture helper. Okay, let's remove this. And there we go. Let's go. And in fact, we could even use this create depth texture in create depth texture, maybe, right? Or no? So 2-dimensional format to be width. No, this one is using sampler and this one is using. Gotcha. Okay, fine, whichever. So next, what we're gonna need else? Pipeline attributes, vertex struct, and create sampler too, and it's the texture helper. Where's the create sampler? Here we go. And let's go. Now, where's the actual app code? Well, let's go to the main.zig. Use it. Oh yeah, update mesh.zig. Yeah, I forgot about that actually. We gotta update mesh.zig too. Yep. And there we go. Okay, sick. Now use it in main.zig. Now use it here. Textured quad. Okay, let's try. But instead of this shader, where is that shader? Where? Oh, actually, I think maybe it removed the. Did it remove my? No, it didn't. So it kept it. So that's sick. Love that. But what I'm gonna do is let's look at the shaders that we have. We have textured quad with matrix. So that's what we need here because we have like the MVP, like the camera. So we gotta use that. Textured quad with matrix. Let's go, and boom. Now, that should work. Scalate, welcome to livestream. Hey, I tried learning SDL GPU, then I switched to Vulkan for deeper knowledge, or maybe because I hate myself. Maybe both. At least that's what it is for me. But yeah, I really enjoy SDL3 GPU so far. Although we're gonna be missing on what is it called? Like the newer Vulkan features, like ray tracing and all that crap. But honestly, anything to avoid that mess of swap chains and like bindings, like descriptor sets, and oh my god. It's insane, bro. It's insane. No field name type. But what's really useful in Vulkan that I found is that sometimes I feel so like sluggish when programming. Like I haven't like programmed in a while or something, and like my brain is just blank, so I just go ahead and and like create some new Vulkan application, and then I get back into speed, into programming. But yeah, whichever. Anyways, no field name type. Instruct GPU texture. Let's see. Where is that? Not two-dimensional. Bro, what? Where is it? Core. So instead of this, we gotta say. Well, we're just gonna remove that. Yeah. And what's next? Misinstruct field offset. What? Take build run. And no field name W instruct. What is it called, bro? What the heck? Text W, I guess? Where is that? There you go. And dot height. Text H. Okay. With height HD. Let's remove this part, and I think that's called depth. Depth equal 1, remove this. Okay, couldn't find the shader, I would guess. No such file or directory. Let's go back into the shader path that we have here. Where is it? Where is it? Where is it? Oh, it's called textured quad color with matrix. No, there is this one, textured quad. Did I spell that wrong or something? Oh, I see. I see. Let's go to where we were. Yeah, let's go back to the textured quad here. And what is that called? Let's see what kind of... They're using textured quad.frag. Yeah. What? Okay, I mean, that's interesting. I am not sure what's going on here, but... where did we actually upload the texture? I don't think we have uploaded the texture, bro. Yeah, we haven't. Definitely we haven't. Like... Yeah, it's just creating a texture. Oh, it's creating a dummy 2x2 checkerboard. What in the world? Bruh, really? I'm confused now. What it did here? Pixels. Oh, okay. I see what it did here. It just like generated some pixels and like slapped them into the texture. Ah, okay, I see. So that's meant to be a checkerboard, huh? I didn't like notice that, but it's using the wrong. Yeah, it's using the wrong filtering. It should use nearest for that. But like, where it's creating the sampler though? Where's creating the sampler? Here we go. Yeah, it's using linear. But for that to actually work, you have to use nearest, obviously. And that would be a checkerboard. There we go. Though there is some like white dots appearing for whichever reason. I'm not sure why. It's interesting. But yeah, that's cool, but this is not exactly what we want. It should have added like a helper to upload the texture. Now, let's see. So where's the texture.zig? Oh, we don't have texture.zig yet. Gotcha. I mean, we could just add it for now into core.zig, I think. Sure, I'll check it out, definitely. Okay, so let's go back. And now what we're gonna do, we're gonna add a texture upload helper. Though it seems like it's not handling like, let's say, multiple textures, but it's fine for now, I guess. And oh my god, it's like changing my damn fields again. My god, I hate that. Don't change any field names, please. What's special in Zig? I just like it. And hello, Goblin Slayer, welcome to the livestream. To add a texture upload helper to your core struct, we need to create a function that handles the transfer of raw pixel data into a texture. Alright, so let's just copy this function. And I think it should be good to go. It like changed my damn fields again. My god. Depth of 1 and we're good. Cool. Now that's great. Now use it here. I mean main.zig. Okay. Well, actually we need also a function or like a helper to load a PNG first. I mean, we could steal that maybe from my Vulkan project. Like if we go to texture.zig, or we could just tell the AI and like give it an example of what it looks like. Yeah, we could do that. Add a PNG loading helper inspired from this Vulkan code. Load the image equivalent of old. Okay, let's try that. App core.zig, right? Yeah, we should definitely put this into its own like texture.zig at some point, but for now, maybe this would work. So this is not the case apparently. .lloyd, no. I'm not sure. So what subsystems we have here? We have audio, camera. I mean, yeah, it should be pixels maybe, but like where? There is pixel here, but I don't think, no. There is surface subsystem, I think. There you go, surface dot lloyd. No? Dot init? Yeah, let's go. And here the width. Wait, what? No. Let's use lloyd, I guess. But how the heck are we gonna lloyd that? What? Init from, oh, okay, from PNG. There's even init from PNG IO, which takes a stream. Is this like a zig stream by any chance? No? No, it's just like an SDL stream. Okay, I see. So let's just say init from PNG file. And the path is, well, path. And we're good. Now, converge. Converge, RGB A32. Converge. Is that really the right one? I mean, I guess. Cool. What's next? Yeah, okay, that seems fine. That seems good to go. Load texture from, or like load texture PNG. Yeah, cool. Now use this in app.zig. Now later on we would want to like upload each, like all the textures in one transfer. In fact, maybe even all the data in one transfer for max efficiency, but for now this should work out just fine. So there we go. Now let's go to main.zig here. And here's the texture. Okay, so let's remove all this business right here. That's insane. Yep. There we go. And what it did add here, no, actually it's fine. Yeah, I guess texture, here you go, texture, and the sampler there. Let's try this. But obviously, yeah, let's give it a good path here. We do have some content images here, so that's great. What if we say content images? I'm not sure if it did pick up on the base path stuff that I had in core, but let's just go with this. And ravioli. There's no ravioli.png. There's armadillo.png. Weird, what is it called? Weird image, but okay. I wonder if this would work. Let's see. Oh boy. Okay, it works. It works. Though I really not sure what it did for the... Where is it? Let's see. Yeah, it just gave the path directly here. It didn't use that base path stuff and so on. So, I mean, if it works, don't touch it, I guess. So let's just say add this changes and say this is the texture. And let's commit sync changes. Okay. Okay, what we gotta do next? I'd like to add the Skybox, like our Vulkan series. Though, but before that, we should at least maybe like abstract possibly the texture stuff, I guess. Do we really need that though? Yeah, what do you guys think? Right, so far we got textures, 3D, we got a camera even. What we're gonna do next is load the texture PNG. Okay, let's ask the AI and see what it's gonna say. What should we try to implement next? I wonder if there's like some lighting shaders here, by the way. Wait, let me see the shaders we have here. I don't think that's the case, but yeah, there's no shaders. There is like compute. We could try some compute stuff. Or we could make like work on a Skybox. Yeah, working on a Skybox, that would be cool. Since you have MVP, dev testing. Now let's not touch lighting yet. Lighting is a huge sink. Like you could go as crazy as you can get with shadows and all sorts of things. Yeah, I think let's maybe implement Skybox and then maybe we could end the stream. Oh, that would be insane. Let's see. Actually, yeah, I forgot, bro. I forgot. I wanted to do loading of the meshes, like of OBJ files. Yeah. I forgot completely. Let's do that first. Oh my god, I actually forgot about that part. Okay. So how are we gonna do that? Well, I'm gonna go back to my Vulkan project here and let's go to the... First of all, I'm gonna download this Viking Room OBJ and stuff. So let's grab that and let's get it here into I don't know. For now, can we just put it in the root directory? I don't know. Bro, what the heck is this? Whatever. Okay, we got that out of the way. Now let's grab our texture here. Not this. Where's the texture? Viking room. There's the Skybox here. And the Viking room.png here. Let's download that texture and let's go. Here we go. And now what we're gonna do, we're gonna use the AI again we're gonna give it this mesh to get inspired from, because we already done the hard work here. I mean, we could probably just like copy this all together mostly. Where we're using the GC here. I think we're using the GC only in here. Yeah. Yeah, pretty much. That should work, I guess. Okay, let's try this. Let's just copy this part and let's go to our mesh.zig and add this. Now instead of GC, we're gonna grab core, and we don't need any command pool stuff here. So we're just gonna say core. There you go. And here, just gonna give you a self, well, mesh. And for OBJ, we're gonna grab this. And arrayless vertex. Yeah, we should definitely put the vertex here instead of core, to be honest. So I guess let's do that. Why not? Core is becoming humongous at this point. Where's the vertex? There we go. So let's grab it from here. And for now, let's just say pub const, or like just const vertex is equal to import mesh dot zig. Though, nah. I wonder if that would make like some sort of, yeah, I'm not sure how zig handles that, because like mesh.zig would be importing and have like a cyclic dependency. You know what? Keep it, please. I don't want to deal with that right now. Keep it, and let's just do the regular thing right now, which is to do const vertex is equal to core dot vertex, too simply. And let's go. And now what we got here, and we got vic3, we need vic3, let's add that too. Fine, or honestly we could just, I mean, we're only using it once here, so just say za.vic3. Actually not once, but this should be fine. Now instead of this, we're gonna say dot, oh, there's only init cube here. Alright, I see. So it's basically just this part right here. Okay. So let's just create a pubfn init self or error, and here core. So let's grab our core, and we need like a vertex kind of slice, vertices. And with that, we don't actually need to give it this address of thing. And finally the indices, which is going to be a slice of U32. And let's go. Now, instead of this business, we should be able to say return dot init core vertices and indices. And let's go. That's for the cube. And for the obj, we're gonna say return dot init core. Oh boy, what? I'm not sure why it's... Ah, I see why. Let me rename this to core, and let's go. And here, let's pass in the vertices. Ouch vertices, right? Let's see, ouch vertices, ouch indices. Yeah, probably. There we go. Okay, let's try to run this so far, I think. Array literal, oh yeah. Expected type, core vertex found, const. What? That's weird. Oh, I think here, right? Wait. Oh, it's probably because it's constant and it doesn't like that. Maybe. There we go. So right now I still have our code working. Perfect. Now what we're gonna do instead is we're gonna come here, and instead of init cube, where's init cube or whichever? Init cube, what? Go to main.zig, please. Init cube, and instead of init cube, we're gonna say init obj. And here we're gonna give it the core, well, address to core, I think, and the data is data. We're gonna like import file, I think, or like include file, embed file. Yeah. For now, let's just embed it, and we're gonna go with Viking room, the obj. Though to be able to embed it, I think we gotta make sure to have this inside of src for now. And let's go. Now, no field name pause. That makes sense. Okay, so we're gonna call this position. I wonder if it's like the same. Expected type core vertices. Oh yeah, the items here. What the heck is this, bro? Okay, let's change the texture now. So the texture, instead of this, let's grab that and put it there. Why not? Images. Let's put that there. Fine. And let's just say Viking room.png. And let's go. It works. It works. Okay, So what should we add next? Should we try to add the Skybox too now? Yeah, we could probably do it very quickly because we have the Vulkan code to get inspired from. And by inspired from, I mean the AI to be inspired from. And we also have the texture stuff, but alright. What do you guys think? Should we add a Skybox now? Skybox. I mean, yeah, I guess let's go for it. Let's go for it. So here we added obj mesh. And let's commit. And if we add the Skybox, we're gonna be basically covering all the Vulkan series in one string. So, man. Okay. So first, let's actually steal the make the Skybox blue. Okay, so let's actually steal the Viking room. Well, not that. I mean, bruh. Let's steal the textures of the Skybox here. Alright, so how are we gonna do this? Texture Skybox. Yeah, I guess I just gotta like deploy this whole thing. Yeah. Where is that stuff? Go to Chakuzik VK, there we go, and textures. And yeah, let's just grab this Skybox, I think. Or yeah, whichever, let's just move it. Nah. Wait, there we go. And there we go. So now what we're gonna do. Okay. So I think I'm gonna make the AI extract the texture.zig first. Maybe? Or no? Or you know what? No. Let's just go with the least amount of changes for now, I think. Yeah. Add support for texture layers. And let's go. So we can implement a Skybox. And yeah, right now we have layer count. As of the cube map PNG, I forgot to give it this. Wait, where did I do that? I think probably in app.zig itself, or maybe not. No, actually probably in core. Yeah, probably. Like, let's look for cube map stuff. Cube map? No. So maybe in app.zig? That's strange, but... Or actually texture.zig, yeah. Yep. Lloyd cube map or what? There you go. No, not this one, this one. There you go. Do I really? That stuff is just for Vulkan, I think. Yeah, that stuff is just for Vulkan. So I'm just only care about, I guess, this part right here. get inspired from this Vulkan code. Okay, let's see what's up. So create texture. Create texture. So we're just adding layers now, which is actually correct. Lovely. Next up, add Lloyd QMap PNG. Alright. But why it's not using that? Oh, I see. They're just like using one command buffer to upload all the textures of the... Yeah, gotcha. I mean, whichever floats your boat for now, at least. Later on, we gotta do better. But anyways, next, important notes. Create texture. But wait, let's see the Skybox shader that we have right now. Okay, let's upload this. Okay, and let's go to app.zig now, or main.zig. Now add the Skybox. So we're just going to create a new Skybox pipeline. Right, depth test, true. Draw the Skybox first. Yeah, generate the whole, or, you know, I guess let's just do it ourselves. Fine then. Yeah, fine. Let's grab this and let's go to the main.zig, and we're gonna load the QMap where we're loading the textures and stuff. I mean, we're doing one here, so let's do this. And is that right? So no, it's like negx and stuff. ls content images Skybox. Update the list. There you go. And where is that? There we go. Let's do this and we're good. Next up, what we got. So we're gonna steal this Skybox pipeline, release standard mesh, and where are we gonna do it? I guess, I mean, wherever floats your boat. Gemini, not ChatGPT. Gemini have a bigger context and it's much faster. So, and hello, Steve Clark. Welcome to the live stream. All right. Where I'm creating the pipeline. There we go. Okay, I'm creating it here apparently. So can I just create the Skybox pipeline here? And we're good. And is it really called Skybox.frag and stuff? Let's see. Skybox. Yeah, there is skybox.vert and skybox.frag. Yeah, that's cool. That's cool. Love that. Next. So drawing the skybox first. So let's go to the render pass here, and before this, we're gonna do this. And next up, we're gonna do the sky camera stuff. Sky mesh. Huh. I'm not sure what sky mesh it's talking about though. What? Oh no. Don't tell me. Wait. Let me see that shader again. I guess it needs like a mesh. The way that we've done it in Vulkan is that we just like had a full screen camera kinda. Yeah. Let's see what it's doing there. Where is that thing? Textured quad. Yeah, Skybox for Verge. I'm confused. What? So no, there's no shader like mesh here. What? Which Skybox mesh? Did it like create some Skybox mesh? No. Oh, actually it did. Init cube. Okay. Whatever. If it works, I guess it works. Although I don't think it would work, because like init cube doesn't take into account like the size. So, I mean, you know what? Let me just go with the flow and see what it's gonna do. So that's something. And here, what's up? Cube mesh. Oh, we're like still drawing the cube mesh? What? Bro, what? Oh no, it's just called cube mesh. So this should be just like mesh, yeah. And here's our sky mesh. And what we're gonna do now is, well, we're just drawing that sky mesh. And then we bind that stuff. Yeah, I mean, let's see if this works. I don't know. Yeah. What's this about? Okay, so here just one layer, please. Though I should probably make this into a struct instead and have like a default of one layer. But anyways, we're good for now. Oh man. Dot type. Dot texture type it's called. There you go. Now if layers is equal to 6, then it's a cube. Okay. Else if layer is greater than 1, then 2-dimensional array. Else 2-dimensional. Alright, but how about... yeah, whatever, okay. And it keeps on renaming this. Unfortunately, I have to like correct it every single time. And no field named position instruct camera. Yeah, that's not gonna work. Let's see how we've done it in the like Vulkan code. So if we go to app.zig, right? Yep, and let's see. Like what we've done for the Skybox. There you go. We've done this. I think sky view. Yeah, we actually got the view matrix and such. Bruh. I mean, let's tell the AI that and see. Although I think probably like the shaders are different. Which in that case, honestly, I'm probably just gonna use that shader instead. But let's just see what it's gonna say. Here's how I did it in Vulkan. But it was a different shader though. I mean, let's just grab this part, okay? Now instead of this, we're gonna do this. And let's see. Gotta go. See ya, mucho. Bye. No member named Malt. I guess mold, not molds. What the heck? Bro. So actually it does work. Skybox works. But we're not seeing our mesh anymore. Why? I don't know. Could you also stream to build your own GUI lib in Zig? I always wanted to do that. I always wanted to like figure out what the heck is going on, like how the heck do you create a GUI library from scratch? But oh boy, that's gonna be a lot of work. But you know, right here we're actually making a little SDL3 GPU wrapper, kind of like, you know, this whole core.zig. Actually, I'm gonna make it into a library, and so we could use it for other projects. So yeah, that's gonna be interesting, but we'll see. Oh. Oh, I see what it's doing there. I see. Isn't the problem that the cube is just too small? Otherwise, can you just modify the helper function first to allow us to disable the depth writing or whatever. Okay. Let's go to create pipeline. Oh man, let's go. Create pipeline, and we're gonna do this. And let's grab this pipeline info. Where's the, there you go. Oh, it's already have added that. I see. That's okay. Now I guess we're just gonna like disable it or whatever, right? Yeah. Now Skybox pipeline. There you go. Depth test, depth right, false. Now watch. And there's no member less equal. Huh. Less or equal, okay. So it does take quite a long time to load like the images of the Skybox. And it actually works now. Oh, finally. God. That was insane. That was insane. Okay. So I guess we'll probably just end the stream at this point. We got pretty much all the progress that we've done in the Zig render. Like in 10 hours. We've done it in how much time? 5 hours. Not bad. But you know, like we had all the code kind of ready in like Vulkan. So a lot of the stuff we just copied from there. But we were like stuck in some stupid bugs. That's why it's much longer. But yeah, so that was it guys for this stream. I think we'll definitely like stream tomorrow again. Goodbye Comporter Box, goodbye Mucho, goodbye Steve B. Clark, Goblin Slayer, Scalit, Alonze, and who else? Aslam Luachi. Okay, Wizifix and Intribe. Data 043. I can only do this because like there is not much chat messages, but at some point I'm probably not gonna do this anymore. But yeah, Chunkus Dunkus. Okay, so yeah, thank you all for watching and see you in the next one. Goodbye everyone.